Grab that over there. So there's a document in the build Brigade directory that's using Git repo to manage Git repositories with Garrett, which should give it's a rough outline of what I'm going to talk about. So let's see here. So what does Repo do? Repo is a tool it's a command line tool that's built on top of Git. Google built it for the Android project. It simplifies when you have to manage a project that has multiple repos, and it's designed to work with Garrett. It has a bunch of special features that work with Garrett to allow you to upload and download code and easily get things through the review process. So how does it work? You can download it from the repo website. Let me grab that. And installing is pretty easy. I have a system here that, let's see, this assumes your root. I have another chunk of stuff that I can install. So I'm just on a test machine. When you start off with Repo, I'm going to use the Cord project because it already has implemented this as an example. You run repo init, which grabs a copy of the grabs a manifest XML file, and that manifest XML file has all of the details of all the different projects that are a part of the repo. This is what one of those looks like. XML, it has a line per project, which is a line per Git repo that's in Garrett. We'll have a path, which is the base path within the project, and then the name. This is the name of the Git repo. Now, don't do this. Don't have a different path, final path component, and repo name. This is super confusing. Everybody hates this. So in this case, we have a Git repo named Cord that's checked out with a path of build. We have a few other places like ONOS apps is checked out as Cord or ONOS publisher. Never do this because it will cause you pain in the future and it'll cause lots of confusion. So that said, most of the other ones are right. For example, in this for this config ONOS app we have, its name is the Git repo's name is config, and it gets checked out to this path. So when you go ahead and you run Git or repo init, you get something. I'm running repo init to grabbing off of this Git repo. I'm going to grab the master branch, and I'm going to check out these groups of directories. So it goes through, it can use GPG to get those. I believe right now it's asking me for my name, and these are Git credentials. And it will initialize it, it'll download a copy of it. And so then you'll see that there is now a repo file here. And so let's do this. Now what it's going to do is it's going to go through and download all of the individual Git repos and check them out on the local system, and it'll build a directory tree. Okay, so now you see that we have some of those directory, some of the directory tree that was created. So, for example, build and build has 2 subcomponents. You can put things within directories within directories. You do have to set up your own gitignore files to ignore them. And you'll see that in there's a repo directory that will contain that contains the same file, XML file that describes what gets shipped.
So Zach, the like when you have these nested subprojects, you're saying that you have to at the build directory you have to have a gitignore file that ignores mass and platform install.
Yeah, and so if you look here, there are subrepos that get ignored in the gitignore file. So you do have to create those. Or it will try to include them as you would with any cascading thing. So as opposed to using, the other option is to use
submodules?
Yeah, submodules. This is a way to not avoid using submodules with Git. In some sense. It has some other nice features that we'll go through. So that was a Git init, there was a repo init, and a repo sync. So now that you have these, you can do, and you have some sets of directories, you can do repo status, and it says nothing. There's nothing that's changed about this. If you want to, if you look at your Git history, so let's go into the build repo, you will see that you're not currently on any branch. So when repo checks things out, it doesn't create branches automatically for you. So if you're used to doing like a Git clone and ending up on master, you won't be on necessarily be on master. It will point head to the current master commit. So if you do, if you look at the log, the last change was this commit, and if you look at all the branches, you can see what they are. And if you were to do git checkout for master, which is our master commit, you'll see that you're still at the same commit. It just doesn't put you on a branch automatically. Which there are a few little, if you're used to using which branch you're on, or used to being on master all the time, it can be a little bit of a slight change in the way that you work with things. So let's say you wanted to start a new change set. Repo has a command that's repo start. So let's look at, I'm going to change. And so now I've created a change set, and if I look at repo status, it will say that in your build project, I have this change set started. If I do git log, I'm still on the master commit.
So this is like a branch that it's building, or what's the mechanism that what's the change set mean?
Yeah, it creates a branch.
Okay.
And one of the other things you can do is you can create branches across multiple things. So if I get our repo start, another change set mass, and now I do repo status, you'll see that I've created another branch in those other projects. So I can manage I can create change sets across multiple branches. These names and these branch names don't actually get, they're local, they're not pushed remote. Because all your remote interaction is going to be with Garrett, there's a way you can use, when you use repo upload to send a change set, you can specify to send the name of the change set as the tag in Garrett. with the -T option. But other than that, you can view these as being fairly local. So there's you can see the status of these. You'll see that there's nothing that's changed in them. Let's change a file. Let's put a Jenkins file in here. Yeah, okay. So now I've modified that. Repo status will show that I had modified a file in the directory, so you can see all of the changes made across all your different change sets. If you go through and you can do your standard git commit stuff, so it will show you that that's done, and so it has a bunch of junk because I didn't add my name properly to Git. Most people are going to have that already set up on their system. So you'll see that you're on there, your branch is ahead, your working directory is now clean again, and if I was logged in, and because this is not my system, I could push that to, you could upload the change. So try to do this, and it's going to fail, but I didn't have repository rights. But you could upload things straight to Garrett from here, and it'll create new Garrett change sets, and one change set, obviously, per repo,
right.
or per Git repo. You can also download change sets. So now, one of the other things you should know is when you download a change set, it will not create a branch for you. So let's go into some place like orchestration.
So that different projects might use different access credentials, right? So where do you specify that if you want to upload to this part of the project, use this credential?
So the credential problem is because this system, I don't have logged in. This isn't a local system that I have my SSH keys on. I can show you on a different system that has this. I'm just trying to show the new user experience and not with a repo that's been under a lot of that has had a lot of changes in it and applied to it. But I can show that. Or is that
this is Brian. I sort of understood a slightly different question, and I think Vishwa's question was, if all your repos are on the same server, then you can share your credentials across the server. Is it possible to have a manifest that has multiple remotes and push, and then how are credentials injected and managed across different remotes? Is that part of the manifest or something else?
My understanding is that they're not. You would manage those the standard ways you do it in Git by creating different I think in your .gitrc file or your .git directory in your home folder, there are ways to specify which repos use which sets of credentials. That's done at the Git level, not at the repo level. Yes?
In here, you've got your one remote specified. Is it possible to have multiple remotes and then name the projects or something? Or
I do not know. It may be possible, but over in Cord, we're not using more than one remote. I'd have to look into that. I can see why that would be a useful thing to do, or to have multiple, or have, for example, a remote that you could set and have a clone of everything for your own internal development tasks.
Right.
As far as setting multiple remotes in Git, there's nothing preventing you from doing that. I'm not sure if that's going to, if that would break things with repo. Yeah, that's one of those things that I'd need to look up more about how to do. And it very well might be possible, but I haven't done it before.
Okay.
So, are there any other questions?
No, we can continue.
Okay. So you can. So if I look in this container or this project, so I'm not on a branch. If I go through and I'm going to grab a recent change off of here. Grab Sopin's change. So he had a patch set, and this is 3620.
Separate repositories within the same remote server.
Let's say I wanted this patch set. It also is relative to path, so.
Okay.
Oh, and that isn't found probably because 3620.
So now we're starting to see why it's sort of confusing to have the names different, because you have to go to the XOS project on Garrett to see orchestration, or I guess, like, if you had different names here, it'd be,
right.
You have to correlate them.
I would be going to the Cord project to download things that end up in build.
Yeah.
Yeah, so that's a trap I hope you guys don't fall into. So what's this? The syntax is it should be this. Yeah. Okay. So I just had the wrong, slightly wrong thing. So you'll see that it says that it went through, it downloaded the files, and it brought it up to head. But if I do repo status, you'll see that no branches have been created. So it didn't automatically create a branch. All it did was tag or take the code that I had and put it on top. So if you need to download things and you want them to show up in branches, you need to do a repo start and then download somebody else's code, because it moved ahead, but it didn't create branches automatically.
All right.
So that's something to be aware of if you start adding things. There are a few other things. There's repo prune, which goes.
Also, branch out.
What was that?
Speak up.
Yeah. That is, assume that I create a branch in the repo level. Does it create successive branches in the respective separate Git directories?
I didn't catch that at the end. You're creating respective branches in what?
Assume that I create a branch in the repo level here. So assume that this repo is actually having references to 5 Git repos.
Right. Does
it create branches in all the 5 Git repos?
No, it doesn't. It only when you do back when I had the example of repo start. It will, by default, it creates it in the current working directory, this repo. Mm-hmm. Or if you specify paths to other Git repos, it will create change sets in those other repos. So it doesn't create a branch across every Git repository that has been created. It will create it either in the current working directory, or if you specify a name after the name you want for your change set, it will try to create branches in those repos.
Okay, and also when I point my refs in the manifest file, I can specify that I want this branch from this Git repo as well.
You can. I don't believe you can do that. What you can do is you can specify at the top the default revision. And
yeah, but this is the repo level, right?
at the repo level, yeah.
But what if I want, assume that I want 1.7 version of ONOS and 1.5 version of Mininet, something like that?
So probably the thing to do then would be to figure out, either have a patch set that specifies that, or you could go through and do you could do that with the standard Git commands. So you could go into, I mean,
Individual repo and then branch out. Okay, got it. Yeah.
Yeah. So you, for example, if I go into here and look at all the branches, I could switch to any one of these branches if I wanted to. So that would be the way that I would recommend doing that.
Sure.
So the other thing that I just said is I said I'm going to run okay. So I have a couple change sets here. There's a command called repo prune that will basically drop any change sets that either are on master or are already checked in. So if I do a repo prune, you'll see that the another change sets that I made no changes to are now gone because they were redundant and they didn't have any commits on them. But the one that's still, that I do have the one commit on, which is in the build project, it still retains its commit. So
do you know if prune does a comparison of the Git hash or of the change ID?
I believe it does it via Git hashes. It checks to see if the head of the change set is the head of the change sets is
present in
the log.
Okay.
I think that's how it works.
Okay.
I have had cases where, actually, yeah, that's how it works, because if you could submit something to Garrett and as part of the merge there's a rebase,
right,
you end up with a different commit hash that corresponds to that, and then therefore prune doesn't work and you have to manually prune.
Okay.
So, that can be an issue. So now I'm on build and I have this chain set that has a bad commit at the top of it. Let's say I wanted to start a different chain set because I needed to fix something. I'd want to do a git checkout my master commit. So I changed it. So I no longer have my bad commit, and now I do repo start. And now if I look at repo status, it will notice that it says that there's only one branch here. But if I do a git branch, there you'll see that there are two commits, or two different sets of branches of changes. Now, one of the other things you can do is you can midway through things do a repo sync, which is like running git pull on every Git repo that you have, which it just went through and did. If those repos, if each Git repo is not on a branch, it will bring them up to whatever current master is. If they are on a branch, it will let you know at the bottom. You'll have a line that says so and so needs to be rebased. This commit needs to be rebased. If you're not on the right, if you have some other commit that it doesn't know about and you're not on a branch, it will throw it away. So you can see that there's that I did a repo download and it discarded that commit because it didn't know where that was from and it wasn't on a branch. So you need to sort of follow the make a branch, download anything you want. If you're trying to work with somebody else's change set, make all your commits, and then eventually, probably before you upload your files, do a repo sync and then a repo rebase. So if I do a repo rebase, you'll see that it's already up to date, and it would, if not, it would take you through the standard git rebase process to rebase your code onto the master.
And this rebase is across all your projects or across the current project?
Repo rebase will work across all projects, and we'll do an automatic rebase until it hits a project where it can't do the standard rebase process. It will stop there, and then you will have to go through and fix things manually with Git.
Okay.
And then after that, you should run repo rebase again to finish rebasing that. I think there might be an option to, when it runs into a problem, to skip and to keep going over those, but I haven't used it, mainly because I haven't been maintaining a lot of patches simultaneously.
Okay.
So nothing but a wrap, bunch of Git remotes. Just swapping Git remotes with respect to the project directory that we are giving.
Well, I didn't quite catch that again. I don't think I'm hearing you very well.
I was just summarizing that probably Repo is nothing but a wrapper over a bunch of Git remotes. So under the hood, it's just running the plain old Git commands. Yeah,
that's correct. It basically wraps all these different commands and interaction with Gerrit in ways that are advantageous, make it easier and less problematic to deal with Git and then also with Gerrit.
Okay.
It also lets you, so if you have multiple commits and you want to upload them all at the same time, when you do repo upload, it will give you pull up your editor and let you select which ones you want to upload. So if you had a change set that crossed across repos, you could upload them both at the same time, which can be kind of handy. So that's kind of everything that Repo does. It lets you create this directory structure. It lets you easily download things and easily upload files to Gerrit and easily rebase the code as other people are making changes across the multiple repos.
So what is the difference between this name item and the groups item here?
So, the groups thing is you could, for example, if you didn't need all of the things in the manifest checked out every time, you might only say, I need the build group, or I might only need the test group or something.
Okay.
If you got to the point of having hundreds of projects in your manifest, and you could easily split them up. In practice, at least in Cord, we check out almost everything every time, and it's something like 40. Yeah, it's something like 40 different commits.
Okay.
So I just looked up some of the documentation, and the things in if you go back to the repo manifest.
Yeah.
You can, so Vishwa asked a question before about, what if I want to lock my project to a specific version or a branch? You can use the revision tag in one of the project as a parameter in a project tag if you wanted to.
Oh,
okay.
And that will lock it. And the other thing you can do is if you have multiple remote blocks, you can have a remote tag or remote, parameter as part of the project element, and that would potentially pull from a different remote.
Okay.
If the project is hosted elsewhere. Now, in terms of managing multiple remotes, like if you had a private server or something, that I think you'd have to do, like Zach was saying, via just a git remote add command or something.
Okay.
Interesting. And then it looks like you can also have projects that are part of multiple groups. So like you're saying, if you had like a test group which had some test drivers or something, and like a production group, you could say like your main thing is part of orchestration and services, and so other things may only be required if you're pulling that group together. So how does this work with your build system, Zach? How does Cord kind of, is each project built independently, or is the build system sort of aware of all this stuff?
Well, right now our build system is using both. It uses repo and checks out all the repos. So, for example, when we need to have Jenkins jobs that run for validation of things, they are doing they clean they delete everything, then they do a repo init and a repo sync, and then they run repo download with the Garrett patch numbers and pull those patches off of Garrett, and then run all their test and validation code, and then get back to Garrett with through Jenkins. So
how does can it correlate between multiple patch sets? Like if you have, like, let's say you do a repo push and there's 3 commits across 3 projects, does it correlate across the 3 in Jenkins, or? Okay.
No, it doesn't. So it doesn't solve the problem of I have 2 changes that span 2 repos that are dependent on each other, and without both of them being present, your build is broken. For example, if we've had some cases like that, and we've had the special case that, or have people override Jenkins in those situations.
So we should have project-wise Jenkins rule once, and then after making sure that the code is buildable, then finally once a release build can be made using Repo.
I didn't follow that.
Like every project is tied with Git, right?
Yeah.
And then Git can, and then that particular project will have some list of commits, and for every commit that you're doing on that particular project, there'll be a Jenkins build to validate that.
Right.
So there's something like a UT.
Yeah.
So once everything is complete on all the projects, then probably we could use Repo and tie it to Git, so that the moment we give a build using Jenkins, it'll just take the head part of all the projects and then build it.
Yeah, so to build like a master branch, or to build like a particular distribution or whatever, where you've tied, this to a particular branch, yeah, that makes sense. But I guess the challenge of having a developer with multiple commits across multiple projects that are codependent, that part, it seems like, yeah, you have to kind of do one change in a backwards compatible way, push that up, then make your other change, and then go back to the first one and like deprecate or remove the old stuff or something.
That's correct, and that's what we've had to do. It ends up making the code more stable, or well, maybe not stable. Maybe it forces you to think about your dependencies more, which can be a good thing, and it can be more isolated, so you don't end up sort of. We had some issues where, especially with configuration or with certain build steps, we had put a lot of configuration across multiple repos, and it just forced us to reevaluate that, probably for in a positive sense. So that's that is something that you do need to be aware of. But if you work out your different repos in a way that your different Git repos in a way that is fairly well isolated, it tends to work fairly well.
Okay.
I think this comes back around to, I think one of the other discussions was on how we end up disaggregating the code, and so that's the tool is one part, the process is totally another, and how you decide to split things up. I could probably give some advice on at least some of the, don't do it this way because you'll run into trouble there.
Okay, so one other sort of related question. What's the local build tool you guys use? Is it Gradle or something else kind of tied to? Sorry.
So we were using Gradle.
Okay.
Gradle is not the right tool for this. I'll just say that you guys were saying about how having a 10 or 15 minute build time was annoying. For us to do an end-to-end test takes 3 hours. And that, because basically we're building the entire infrastructure of the project. I I'm working on a project to basically throw out Gradle and replace it with Make, which Gradle's parallel build process isn't the greatest and isn't even well supported, whereas Make, I think I'm going to be able to get down to from 3 hours to about 45 minutes, which is a lot more reasonable. That's probably coming in the next month or two.
Okay.
So, yeah, because we ended up a while ago having this incredible cascade of things where we'd have Gradle running Ansible, then running, in some cases, Make, which would then call Docker and build containers. And so sort of stripping out different layers of that has gotten us either a lot faster or a lot less complicated. But it sounds like you guys have your own build system, and honestly, because you're building things that are well known to be easily parallelizable, and that can be that have a standard dependency model. I think you'll probably have better luck than we do with moving to a system like this.
Yeah. So I mean, one of the sort of the history there is, I think Google was using a primarily Make-based build sort of infrastructure to tie everything together. One of the challenges with Make is that Make typically uses timestamps. So if you've got a distributed build environment, timestamps aren't reliable enough. Also, when you're checking out new branches and stuff, Make may not retrigger. You may be forced to do a clean. So they built an internal tool called Blaze, which uses hashes on the inputs to determine whether some work has already been done or not, or whether changes have been made. And then if you can define your build steps, and this is where Buck has a bunch of pre-built rules, and then the extension mechanism of gen rules isn't like fully generalizable or fully useful. But there's another tool called Bazel, which is an open source version from Google of their internal Blaze stuff without the distributed build framework bit, like their build clusters and stuff. And their API for defining build rules is actually fairly flexible. And so you can define dependencies between rules. You can have fairly arbitrary logic that's written in Python rather than Shell to sort of define the build steps. And then, for example, if there's one part of the code base that keeps changing and you want to do a complete rebuild, it will look in its cache and determine that it's already done the work. You switch branches, it'll look in its cache and determine it's already done the work. So it definitely makes the builds slightly more reproducible. They're designed to be parallelized because the inputs are well defined, dependencies are explicit, and the outputs are deterministic. So
that sounds really interesting. The path that we're going down in Cord, this is totally off topic, but the path we're going down is sort of a microservices based, everything is a container model, which brings into the problem of how do you know what code is in what container and what has been built. And so Docker has some things about being able to tell which whether its input in its build context has changed at all, because it basically creates a tarball of every build context before it passes it on to the Docker engine to create the container. So we're also working on, I have some tooling that is doing some special labeling and tagging of Docker files depending on, and comparing them, that understands repo and understands Git and can tell if there's been a change and can tell if a container needs to be rebuilt, and then rebuilds those containers as need be. But we have both that and we have build steps that are provisioning systems using Ansible. So that has its own.
Container will come only in case of a deployment use case discussion, right? So we have code and then we build, we create some artifacts, and then it's up to us to either run it in the same server, or we can run it under a container, right? But I'm just trying to understand how a build system is being tied to a container during the build time.
So the way that it, well, historically we had containers that were built by either by Ansible or by Gradle, or even by, in some cases, we would call a Gradle would shell out to make, and make would run and create those containers. I guess the problem was basically you had, once you'd built the container, you knew that you built the container, and you wouldn't be able to work back which source code that came from, and so so our process was basically to use the labeling and tagging functionality and have a to generate those or to build the containers, but then also apply versioning information to them so that we could decide when to replace them if things changed in the build environment. But that's because the artifact format didn't let you have versioning information in it, and we had to sort of tack that on. Probably in some ways similarly to like the ways that you had to some of the Buck stuff to work to do things that it doesn't come out of the box doing to build ONOS.
So Zach, I haven't actually played with this, but I just did a quick search, and in the chat link, I shared a link. Bazel actually has built-in support for kind of creating Docker images off of artifacts that are part of your main build. So, for example, in their basic example at the top, it looks like they create like a basic Wheezy image. They have a file. It's sort of like the export file in Buck. This file group where you can define some files to be tracked. So they have a CA certif steb that's produced. That could be produced using other rule, for example.
Right.
And then basically they can build their base image using CA certificates, build their Java image by including, by building off the base image and then adding the OpenJDK JRE. So I'm not sure. I haven't played with this, so I can't speak to how easy or hard it would be. But in general, what it would be able to do is it would be able to say, oh, this Docker image was based on these explicit dependencies, which are files that get added or work that gets done. And then it would be able to detect whether or not the dependencies have changed, and would be able to determine whether or not it needs to rebuild the Docker image.
But can't we just wrap all these commands and expose it as a generic rule? It still can be done, right? We have set up artifacts when we want to cook the container image. That is something that's set up some commands.
Yeah.
We can also wrap this under a shell script and then expose that as part of generic rule, right?
For a Buck?
I mean, for any build system.
Yeah, sure. Yeah, I mean, basically, the way Bazel works is they've got native plugin support. So if you look at the load directive at the top, you can either load rules from within the source tree. That's kind of like our Bucklet style, or you can load rules from the web. Like, so if you publish like a Docker rule or something on GitHub, you can like export these macro type things. There's kind of less of a notion of macro because their build framework is sort of more flexible, so you can, like within a build rule, kind of have macros or define new types. Okay. It's a bit better, I think, from an API perspective. A bit more is exposed to these build rules. But I don't know. It's sort of worth a look. I'm not trying to derail the work you're currently doing, but this might provide kind of what you're looking for.
Yeah, I'll definitely look into this. One of the other things we ran into is we have situations where we want to generate an artifact, and we might want to generate that artifact in a Docker container, but then we don't need the entire build environment that lives around it. So for example, we have some tooling that was built with Go, and we didn't need the whole Golang compiler because Golang binaries are static. So
we have the runtime and everything built in.
Yeah, one of the other things that I've seen is that Google has this cloud platform container builder, which allows you to do multi-step Docker container builds that leave a workspace directory. And so you could put things in that workspace directory, run your build step that involves all your compiler tools, and then do another step to package them into a container that you actually send out. So that's one of the other things we were working towards. So I'll look at the Bazel stuff. That looks like it might be possible to do. We have a lot of people invested in having being able to ship a Docker file and not be totally tied to our build system. So that might be a little bit of a challenge. So, but thanks for letting me know about that.
Yeah, I guess the question is, like, you can build these Docker files that are completely self-contained, fetch the repos from the internet, do all the building locally as part of the Docker build step, or you do that outside and just copy the targets in. I mean, I think the do it outside and copy the targets in. Now you're kind of more tied to a build infrastructure, which is maybe, I don't know, maybe good, maybe bad. But yeah, if you're having the Docker image have to like copy the source, now you need to have the JDK or the Go compiler or GCC available, and then it takes longer to build those images. It's harder to know like whether something's changed, so you kind of have to rebuild it. Maybe like you said, use tags or something. I don't know.
Right.
Sort of depends upon whether like how people are going to consume this, and whether you expect people to be really building their Docker images from scratch, or whether they can be building them as part of the build framework if they need to build their own, and otherwise they're just consuming them from a repository.
So telling somebody to do this as opposed to apt-get OpenJDK7JRE headless might not go over well with some of the people who are writing our Docker files right now. But I mean, this is going to give you a much more repeatable build.
Right. That's sort of the goal. Is that you have deterministic inputs, so that regardless of where you are, either the build does not work because you don't have the dependencies you need, or the build works reliably every time on more or less every system.
Right. Right.
And the nice properties of that is that you don't have to redo work because you know exactly what the inputs were to get started. And you can just pull artifacts out of a cache if you've ever done the work in the past.
Okay, that looks
anyway,
good.
Something to think about. But yeah, thanks again for walking us through Repo. It looks like maybe there are a few gotchas, and I mean I think you pointed some of those out, but more or less.
Almost everything is workflow related. Once you get the hang of the Repo workflow, I find it much easier than my previous interactions with Garrett, which involved creating what was it? You had to create a file that told your Git in your Git repo to tell it about the Garrett remote and those sorts of things. This sort of handles that all for you, and it handles some of the it just makes working with Garrett across multiple Git repos much easier.
Gotcha. Yeah, it seems like it.
Okay. I'm going to turn back over. I'm going to stop screen sharing. Are we going to move on to the next disaggregation discussion?
Yeah, I think that makes sense. I don't know if you have any topics there. We also have Thomas here, who probably has some opinions. So yeah, we can probably. This will probably be a good segue. did you have sort of a plan in this area?
Yeah, I mean, the plan was to just get our hands dirty by taking out the apps part, because that doesn't really have much effect on the core system. So maybe take out the apps repo and make it as a separate Git, and then try to wrap the main build system using that two Git subsystem. But before that, probably Thomas can share his views on code disaggregation.
I mean, my thought was, we first, I think, and I could be wrong, I suppose, but I think we first need to deal with the compounds.
Well, so before you, this morning actually, before you joined, we identified two remaining sort of items to cover. There's, a handful of modules that still can't be built, largely in two categories. One is they want embed dependencies, which is something we can map through, or they need Thrift.
There's two of those.
Thrift or protobus. Yep. And so
once there's OpenStack.
That's an embed dependency.
Yes. Again,
so embed dependencies for OpenStack and for OpenFlowJ. That's one category. So one feature that's required is get embed dependencies working. The other feature that's required is get the generators for Thrift and protobus.
I think that
we have a clear path. Yeah.
I think for that we have a path, right?
Yeah. So we have a path for both. So once those are done.
Third one. Third one is multiple. The fact that right now we're relying on there's two strings in the code that depend on different versions of the end. And our plugins approach right now just one at a time. So we have a set of code that requires 1.11, and we have a set of code that requires 1.12.
So this is a question of whether we want to support versioning in the plugin.
And well, or just fix the freaking thing on the Yang side and just either downgrade everybody and say sorry, or upgrade everybody and say sorry.
Or you expose a copy of the plugin that has a build rule that's called Yang Legacy or something, and then use the Yang Legacy rule name on one.
I wouldn't
kind of
say
like
versioning of plugins. We don't invest in.
Okay, so
just do a hack, whatever hack.
So the hack is just vendor the rule name.
Yeah.
Call the old rule name Yang tool -110.
Yes.
And have a second version of the plugin that runs alongside the first plugin.
Yep.
So this is actually sub point 1, 2, and A, B, and C within number 2. So you can tab that over, yeah. The other subpoints are generating Thrift and protobuf code.
No, okay.
And the other one is support embed dependencies.
I don't want to just be tangent on talking about the code disaggregation, but I think that is something that we probably ought to figure out how to get off the table.
Well, so one of the challenges is that with our current Maven-based approach, there is an explicit dependency between the file, like the file structure. In Maven, you have to explicitly declare your children as modules, and you have to explicitly declare your parents, which is based on a file system relative path.
That's going to break Repo.
So Repo can pull all these things down, but then you're going to try to do a build with some missing paths, and the whole thing's going to explode. Yep. So you basically, as long as there's only one group setting and everything's in that group, Repo will work, but you can't have subgroups.
That's
or
how to keep the purpose, right?
Right. Yeah, because otherwise, why not just have one massive? Well, yeah.
So, but if you were to, so let's say, just so if you take that as an observation, or whatever, figure out how to either handle it or how to work around it. I just want to make sure that that was.
Yeah. So
given
the other one is the Eclipse stuff, and so I think we have a pretty clear path forward for A, B, and C. That's not a ton of work. The Eclipse stuff is going to be a bit more of a pain, I think.
I think I'm willing to say, sorry. There's
Okay.
poor man's versions, people just let them put in stuff, frankly, or put together a quick hack to produce. I mean, they're just freaking XML files.
They're just
How hard
XML
is it?
files, and if you have
And
the
so
IML
IML
files,
files are XML files. So
so
how hard is it?
just generate the generate the IML files, and then just have a conversion
Have a
utility
transform.
that looks for all the IML files and transforms them into XML.
Exactly. It's
So-
an intern project, right?
Okay,
I
fine.
wouldn't
So-
let that block us.
so-
So I think urgency to create that project will be created by the, some
Yeah, someone's gonna be upset
someone's
about
gonna
it.
be upset and is gonna provide a workaround.
Okay.
It's fine.
So I think, yeah, I agree that moving to the repo based, an advantage to move to repo is that you can create these sort of different workspaces, I guess you call them, or groupings, pull them in, and then also, yeah. So on one side, go ahead.
It's also so that your history, your Git history, is per that subcomponent, not across the entire project, which might be sometimes hard to.
Well, you
hard
can
to-
just ask Git to filter the history based on a tree, or a subtree.
You can, but sometimes that's not a. When you have sort of the one Uber repo that has everything in it, it can get a little hairy. I don't know. It also it means that you can, if you have a specific team working on a specific project, they can work on that one project in more isolation. It depends how your project is split up.
Yeah, no, I agree. And different projects are in different phases of maturity, and if you want to deprecate a project from a monorepo, you basically have to delete it or somehow mark it as deprecated, and then it's sort of harder for someone to revive it. With repo, you could just delete the entry from the manifest and then re-add the entry when a project's ready. And yeah, I agree that this sort of symbolic linking approach for this type of project from a social perspective and sort of an organization perspective makes a lot of sense. So yeah, okay, fine. The thing is, yeah, we can't have the Maven build work across this sort of dynamic workspace environment. So we need a static workspace environment with Maven, but okay, we'll get these things done, delete the POM files, and now we have bugs.
Yep. And so getting back to the code disaggregation, I think the idea of, which is what I think he said, is basically get your hands dirty by taking the apps, or some of the apps, and moving them up.
Or the other thing you can
I think
do,
that
you
would
could,
be definitely the idea. I wouldn't, but my suggestion would be not do all of them wholesale, but just start a couple of them.
Okay.
And start that way. And then once you sort of, because that way you don't necessarily have to apply your learning to, across the wide swath of code. I think I'm not suggesting that we procrastinate much beyond that.
Mm-hmm.
Do a few of them, and then after that, you can do all of them.
Okay.
Or potentially, whether you have that many, we have 100, right now we have 100 different apps. Now, they don't all come from slash apps. Some of them come from slash protocols, some of them come from slash drivers, slash providers or slash drivers, right? But I think we start with the slash apps.
Okay.
And then potentially maybe have, a group of them together in a single repo, not necessarily one pair. Otherwise, you're going to have probably 50 repos right from the get-go.
yeah. Well, the other possibility, right, is if you didn't want to mess with the code while this stuff is taking place, you could experiment with building a manifest file and then trying to layer some of the ONOS app samples apps into the tree.
It's a great idea.
Yeah.
Actually, that's probably
Because then the regular code base stays the same. It doesn't impact anyone while we're experimenting with the manifest repo stuff.
Yeah.
And then you just layer in a few extra apps that are not going to be plugged into the Maven build, but it doesn't matter. And they'll be available as buck targets if they have build files.
I like that. That's a good idea.
So for the building of the total aggregated source view, Buck is not going to have a problem with Buck files that appear arbitrarily.
Yeah. After
Also-
that, the path is maintained, the existing Buck rule still holds good, right?
Right. So the path is independent of the Buck file, and so you can take these Buck components and place them anywhere. Now the question is going to be the dependencies. Like if you know that this thing is always going to be placed at slash apps, whatever, and it's always going to be within a workspace that contains API and core and everything else, then yeah, your paths will more or less work out. But these apps repos are not going to be buildable independently, because if you just check the code out and try to do a build, it's not going to be able to find any of the relative path dependencies, or rather absolute workspace path dependencies.
So
which is I guess a higher level question we have to ask ourselves, whether or not we want these repos, these sub repos, to be buildable if someone just goes and downloads them and wants to build the code, or whether we have to say, oh, this is really just a sub repo that's part of a larger project. If you want to build it, you have to go and use the repo tool, check out the entire source tree, and build the whole source tree by yourself.
we went the latter route, using repo, and we have things that basically our interaction with Garrett requires that you use repo. It just turned out to be the right way of things, and the other thing was we used groups to isolate. So, for example, everything would require that you have the build group checked out. I think that it makes a lot more sense to do things that way than to try to build things on their own. While you could say you can check this repo out and build all of its have all the build components within it, then you end up splitting up your build process, or at least the subcomponent build process, across so many different areas that, and you end up with replication of code in so many different places that that's not something that I would encourage you to do.
I completely agree in a sense that I see nothing wrong with having certain requirements for the synthetic source tree. So that, let's say, you always need some build tools, right? Or you always need for apps, you always need the core API, but you may not necessarily need the core. For packaging, you may need the, build tools with everything, the API, the apps, and the implementation.
Yeah. So what you're saying is for particular groups or for particular repos, there may be a subset of the project that is required to be checked out, and it's expected that for this thing to work, you've got to be working within sort of a repo build workspace.
I think that's fine.
Okay.
That will simplify things.
That'll simplify things, yeah. And then you just need to make sure that your build dependencies, the build tools, the scripts, those types of things, the common libraries and stuff are all in repos that are part of a group that can be downloaded independently of the rest of the code.
Exactly.
Okay. Okay, I mean, that makes sense.
I like the idea of the concept.
Just pick one or two apps.
Yes. That way you can try it to do. I don't have to worry about
messing with stuff that
structure
people
until we learned and figure things out. And you can start, building ground.
But then you want to split the build tools across the project. Assume that there's a standalone app. That app can be built even Maven-based style, because we're anyway publishing the Maven artifact. So using the POM.xml also, they can build the app. But then you want the build to happen in a logically centralized way, or you're also seeing that if there's a sub-project that actually builds artifacts, then during the packaging step, I can just grab the artifact that's available in the path.
Yeah.
So, I mean, technically speaking, in a Buck-like workflow, you could support Maven artifact things. It'd be kind of a massive hack. Basically, what you do is you just have Buck watch all the sources in a particular directory, have a general that invokes Maven, and then you just grab the output file and put it as the output file for the general. And then if there are sources that change, it would reinvoke Maven to do it. So you could have a Maven invoked general, but it'd kind of be a bit of a hack. And I mean, theoretically, someone who wants to build apps in whatever language outside of the project should be able to do that, but I think there's definitely something nice about having a coherent build infrastructure within the project, just because it helps developers kind of move between various parts of the code without having to change, their mindset or tool.
But I was on the assumption that the main reason to go for Repo, that to checking out all the Git sub-projects is only during the release time, right? Because every small Git repo, people would be focused only on their project. That's the whole idea of disaggregating the code, isn't it?
Well, I think the idea of disaggregating the code is that you have more ownership and autonomy at a repository level potentially for a small group of people.
Yeah.
Now, in order to produce maybe if you're just focused in your single app or your single provider or whatever, you could have a minimal subtree checked out for the purposes of building and testing that you wouldn't necessarily have to be concerned with everything. But when it comes time to package things
so that will be taken care by someone who is actually interested in building out the entire ONOS project, or maybe during the release time or something like integration test. So I, as a provider focused guy, I'll be happy if I can able to build a provider and just use it in a running ONOS. Unless my feature is not gonna mess with other projects, only then I'll be able to check out. I'll be interested to check out that project as well.
So I think what you're arguing for is that for like an application thing that you want to be able to build without using Repo, like check out Git Repo and build your project without having to worry about a workspace.
If I am a guy who's working on provider subsystem, then I can just view provider as a single Git repository, and then I can use my own way of just checking out the provider app and then doing the unit tests and stuff like that, and then checking the code. But then you are actually a release guy who is actually checking out the entire ONOS subtree to cook out a release or do some integration testing. You might be interested in using Repo to actually grab all the other sub projects to cook out a complete build. So as a focused team, I don't want to use Repo to build the entire ONOS subtree, right?
So just to chime in here. Repo is actually, and Repo and Garrett are actually quite fast. So I get the feeling that having a full Repo checkout of the full source tree, including every other repo or every other Git repository that is included in it, is not something that would cause problems with that. I think it's easier to have one process rather than to try to support multiple processes. We tried to do that for a while in Cord, and it was not a successful thing because people got to have two different of working processes. So I would.
If everybody is going to use Repo to actually check out the entire ONOS source tree, then why are you going for disaggregation in the first place?
So for the other reasons.
Whether I want or not, I'm going to check out the entire source tree.
No, but the thing is with Repo, you don't have to do the whole tree, right? You can just check out certain groups.
Right.
Yeah.
You could
check out the idea. So you have the API, you have the core, and then you have the satellite thing. You have the drivers, the providers, the application.
Correct. Yeah.
And so we want to push as much code outside of the core towards the periphery, towards the drivers, providers, and applications. That's where most development should happen. The platform itself needs to be as minimal as possible. So even if you do have to check out, let's say, the API and the core, then you just handpick which and build tools, right? Of course. But then you can handpick. If you want to work on application A, you can pick that one. You bring that. Applications, for the most part, will be independent. Now, there will be some dependencies between some applications, clearly. But for the most part, that's a fairly sparse tree once you get from a periphery. It gets pretty dense. Everybody depends on the API. Everybody's going to depend on tools. But not every application will depend on every other application. And so that's where you start saving. You don't have to pick everything. You can pick groups which are tailored
but then we'll have to ensure that all the workspaces that we actually provide should be self-sufficient in building. Like you should not miss something. But that's the point being suggested, right? Because assume that I have some workspace. Sorry? Yes, Jack?
Yeah, well, the problem then is that's totally fine if you can make sure that you're not spreading your build code through all of these subrepos. If that's the thing, that if you can avoid doing that somehow and not have a bunch of build specific code that's replicated, go for it. But if it's going to require replication of build code, I'd advise against it.
Oh, I completely agree. It was based on an assumption that the build code and the build tools, effectively, there would be some level of uniformity in building it, and that uniformity would be embodied in basically in a build tool set, which would be required for any, essentially, any subset of the trees.
Mm-hmm.
Okay, yeah, that makes sense.
A requirement. I mean, and we do have that today, effectively, right? We have the tools. That has the build tools, packaging, and test. And I think that, I mean, if you were to think of, that as a potential split point, you could start, after you figure out the mechanics, that's where you could start. You could basically, the slash tools could be separated.
Mm-hmm.
And then would have to be required to be in every workspace.
Okay.
And you get a workspace for working just on the core.
Mm-hmm. Yeah.
And
so people who are working on the platform, but just check out that particular workspace. Like they don't have to have drivers or apps in them.
Exactly.
Okay, so probably we'll start with ONOS app samples and try to get an answer.
Yeah, and I think that can be done in parallel to the obsolescence. Because it'll just be that the the Maven-based build will not include the additional repos that we add, but the Buck-based build could be made workable.
But you said that like we could get rid of all the form files after we do this. Right?
Yeah, after those two things are done, we could get rid of all the form files that are not like dependency form files. Like we want to publish a few and maintain a few form files.
Yeah, this one, right?
Yeah, exactly.
Tools, build.form.
Yep. I think, hopefully I didn't forget any, but I think
it's basically the base form for like plugin versions, the dependencies form, so people can have the dependencies that are the same as the ones we use in Graph.
And that would be generated.
Generated, yeah, generated that form, which we could probably be generating in Ether, I think, but and then. Yeah, the build form, and I don't know, maybe just a base ONOS form which has, the version number and other stuff. So yeah.
So Zach, then probably I think you could get started with taking a look at ONOS app samples. I mean, ONOS app samples is already a separate Git project, I believe.
So ONOS app samples was it's a mini monorepo. It's got like a collection of, I don't know, 8, 10 unrelated applications. And we could pull one or more of those applications out of app samples, create a separate project now, apps/ whatever.
App samples.
Yeah. Well, apps/ my app.
Okay.
And then in the manifest, you'd have ONOS project, which maps to root path, and then you have app samples or something that maps to apps path. And then as we pull stuff out of ONOS project, it would just be put into subdirectories.
They basically just add to the git ignore. Just basically start burning holes.
Yeah. Add to the git ignore as we go. But it'd be nice if we had outside code at first. That way we're not messing with what we currently have.
Oh,
so samples would just map perfectly onto app something.
App something, yeah, exactly.
So one thing that people have been concerned about when we made this transition from a fairly large monorepo was history of changes, and what we ended up doing was, for a lot of things, we would basically, if we were going to split a repo into two, we would put the history of the common history in both repos, and then cut down and remove all of the old, or remove the half that, let's say if you cut it in half, and you had, you would remove the part of the code that you didn't want to be in that repo and from it. Now the downside of that is that you're getting all the history that existed before of the other files, so it works generally a little bit better for the main repos, and then if you have things that end up having like 10 files in them, you don't need the history of the entire rest of the project in it. And in cases like that, we just copied files over. But when you had large subcomponents you were disaggregating, doing things to give the whole history made some sense.
So actually, some of the stuff in app samples started in the main repo, and we sort of had similar concerns and didn't want to replicate the whole tree. So what we've done is we've used there's a complicated Git invocation where you use some combination of filtered branch and some other Git magic. And what it'll do is it'll go through, look for commits that are only relevant to this part of the tree. You basically get a filtered look at all those commits, and then only pull in commits that have relevant state that has contributed to the end state, which is some subdirectory of the project you wanted. So as long as you're targeting a subdirectory, there is a way to replicate the history. Now, all the commit hashes are going to be completely different, but you can create a new project with all the commit message, authors, timestamps, etc. For a new repo, basically. That is
I think we tried doing it, but we could never figure out the correct incantation of the filter tree command.
Okay.
Yeah, we've done a number of times, not just on the ONOS samples, but also on the N2.
On the N2 stuff, when we extracted it, Nemo extracted, yeah. So we've through great pains and much sorcery discovered this incantation, and perhaps we should publicize that.
That would be wonderful. I would love to see that.
Yeah, it's a really nice one. It's a really nice one-liner. Yeah.
Yeah, it was a one-liner basically.
Yeah, you just need to kind of get it right, but
yes.
it's not as complex as the number of it's more complex than the number of characters would indicate.
Yeah.
But yeah, we'll try to share that. But yeah, it's an important, I think, it's an important thing, right? Because I mean, people want to be credited for their work, and also people want to be able to sort of know the evolution of these modules, and they also want like when you want to know who's written something, you want to be able to go look in the Git history or get blame and see. So cool. All right, so yeah, I guess we kind of have a path forward, which is build a manifest, move one of the app samples over, and add that to create an augmented view. And then as we go, if we like the way that looks, we can start pulling off apps slowly, one by one, and then the root project just can gradually shrink.
Yeah.
And that way, eventually,
you have a debate on the workspace naming what should go in what. Then we could just build the manifest file as soon as we go.
Yeah, and then the nice thing about that is the main project gets smaller and smaller and smaller, and then no one has to carry the main project history around anymore. Kind of just disappears. The main project eventually gets deprecated, I guess, or maybe
to follow the distribution of like we have Ubuntu tiny code. Yeah. And then we have the desktop edition. Then we have server edition.
Yeah. Yep. Cool. All right. Well. Okay. Sounds like we have a nice plan. Cool. So I don't know if Ray's gonna turn up today. You know?
I thought he was here most of the day.
Was he? He was out this morning.
Well, I saw him in the morning.
Because then he had something personal come on.
Oh, I thought he was here with you in the room. I didn't see him at the desk. I thought he was here.
We actually had Jenkins pipeline on the morning slot. Since he was not there, we stopped to the afternoon slot.
Okay. Let me see if Ray arrives. But if he hasn't arrived, well, we should probably take a little break, but if he hasn't arrived, it might make sense. I added some additional topics to cover.
Yeah.
These ones from yesterday. So one is a STC overview, like what STC is doing, where the code is, how, where should I look, kind of stuff. We could do a Warden deep dive, both the existing Warden and the Go-based stuff that we've started. And then also kind of walk through the development scripts, like the tools, star bin scripts, and the scripts as well.
Yep.
So I don't know if you want to.
No, I don't think I have anything this afternoon.
Okay, so let's take 15 minutes.
Yeah.
15 minutes break. So we'll resume at 2:40. 2:40. 2:40.
I thought it is already 2:45.
Yeah. So we'll resume at 2:40. And pick things up. And if Ray's around, we'll do the pipeline stuff, and if not, then we'll do the STC work. Yep. Okay. Cool. We'll talk to you guys in a couple of minutes. 2:40 Pacific.
Okay. See you soon.
And I'm gonna go through a little bit of stuff on pipeline, and then we'll kind of do some. I did spend some time building a pipeline for ONOS, which is sitting in our Jenkins, and unfortunately, it somehow corrupts Jenkins when I run it, such that it occupies all the CPU and it chews up a bunch of disk space, and it's just, in general, very poorly behaved. So Ryan was kind enough to stand up a new Jenkins instance, which we can use as sort of a sandbox. We can play with this later and try to figure out what's going on, but I thought I would kind of show everybody what we have so far. So the way the pipelines work is it's basically a series of steps. Furthest most left in the graph you're seeing over here is the beginning of time, and then as you move through time, you move to the right. You can see the last few runs I did failed. I'll show you the nice thing about pipeline is that it runs a script, which is actually checked into the source code. The existing Jenkins things are all based on sort of shell scripts that you write in a UI, which is really not very nice in terms of configuration management stuff. So this is it's much easier to look at what it's doing. So essentially the steps that we have here, so every job has this declarative checkout SCM. That's basically just saying, hey, here's my Git repo, nothing interesting. Pull is what you might expect. That's pulling whatever files have changed out of your Git repo into your current workspace. Build is when you guys talked about Buck this morning. This is basically Buck build ONOS, and we'll see that in a minute. Test is quite a bit more interesting. Test is doing quite a lot in this configuration. It's running unit tests, it's running check style, it's running Java docs, and it's running STC validation testing, all in parallel. And we'll look at that in a minute as to how that works. The declarative post options is supposed to be really quick. That's basically just freeing up the resources that the STC run used. So let's take a look at what this actually looks like. Top. So they have this canonical name called Jenkins file, which is written in a scripting language called Groovy. Dumb name, but they didn't ask me. So basically those tabs that we saw in the UI, you can see pull, build, test. Those are declared in here. This is called a declarative pipeline. There's two kinds of pipelines. I chose to go with the declarative syntax because it's the newer one. I don't know if that's what's causing the issues we're having, and maybe it's not as well tested, but anyway. So for example, you can see in the pull stage, we have a declaration here that says, here are the steps we're running, and that's essentially a set of shell commands. The Warden client business is grabbing a cell for the STC run we're going to use later. This is defining where our Git repo is. And then this Warden client timeout duration business is actually allocating the cell. So that goes very quickly, as you might imagine. All it's basically doing is connecting to the cell and said, you know, give me a cell at some point. I'll go back and check with you later. And then it pulls things via Git. Now we start getting a little more work done here. So here's the build stage. So what we're doing in build is we're basically doing ONOS, Buck, build ONOS, the same way you would on your Mac. there's this little bit of sugar that drives me crazy that I have to add in about setting ONOS root and invoking the M default. There's got to be a way to do this more elegantly. I couldn't figure it out in the time I wanted to spend on this task. So you'll see that same sequence is in everything. That's because Buck needs a certain minimum set of environment variables set based on where your tree is and things like that. Oh, it didn't work without it. So.
Well, so you could, hold on, but I mean, you might be able to just say, like have a relative path to the ONOS Buck.
That could work.
I don't know that I mean, M default just sources the ONOS Buck path, but if you just, I don't know. I mean, Buck should be self-contained.
But there's other stuff in there. There's other environment variables.
Does it? Oh, yeah, whatever.
You're right. Buck should be self-contained, but if there's anything other than Buck, it might be different, right?
Yeah.
But instead of the shell script, couldn't we use some available Jenkins plugins themselves?
I don't know about that. This syntax here, this sh git, those are all built into the Groovy sort of environment that the pipeline runs in. There's a whole bunch of them. I don't know what they all do. It's possible you could do that. I also know for a fact that you could write Groovy code to do whatever you want. It's a programming language. But I just didn't go down that route because I didn't want to spend a lot of time on this. But you definitely can do that. You can write subroutines and do whatever you want.
Usually for Buck, you should not require the M defaults. If there's some other stuff, that's maybe.
I don't remember what was failing, but I did need
something can be cleaned up later.
Some of it, but a lot of this was intended to be a prototype. So
yeah, sure.
So now it gets a little more interesting. So let's see the.
I have a question.
Yeah, go ahead.
Jenkins to access Git, it doesn't have to be to have the credential, the username and password. How does it access Git Jenkins?
I believe that's via public key and SSH. Correct me if I'm wrong, Brian. I think that's how it works, right?
For what?
The way that are you talking about getting into Jenkins or how Jenkins gets to Git?
Jenkins getting to Git.
Yeah.
So Jenkins does have a user on Garrett, but that's for like streaming events to know when to trigger jobs. I don't know if it's strictly required. I mean, it depends upon what your SCM URL is, right? If your SCM URL is the anonymous HTTP one, then it's read only, and it can just do it. But for voting and stuff, yeah, it has a public key credential. I think you can also set it up to use HTTP password based off of it.
I think cloning we can do cloning anonymously.
Yeah, that's absolutely true. Via SSH or HTTPS, as far as I know. Okay. Any other questions before we move on?
No question. Thank you.
Okay. So let's look at the test stage here. So this is what I had hoped would make pipeline worth using. So essentially what we're doing here is in this test stage, we're saying we have a bunch of steps like we did before, but these are intended to be run in parallel. And what it does is it's a very time-friendly and other resource unfriendly operation. So basically right here we have 1, 2, 3, 4 things that we're doing essentially at the same time. So what Jenkins does is it duplicates the entire workspace 3 times for the additional guys, and then brings up a separate job of VM in theory on a separate executor in theory, so that these all run in parallel. So we're doing the unit tests, which is the slowest part of the Buck build, and that will also include the check style runs. We're running Java docs in parallel. We're building a Docker image in parallel, which is quite expensive. And the reason we can do this is because the Docker image doesn't depend on any of the outputs of these first 2 steps. So we can run them in parallel and get good Docker images out. And then the last thing we did was, I don't know, did you guys talk about STC at all?
Briefly mentioned it yesterday. We were going to try to find a slot at some point.
Okay.
But I did mention the Warden that we have locally. So we talked about it. Yeah.
Okay. So just it's basically it's an integration smoke test kind of thing that is going to as soon as the build step is done, whatever's needed to run STC is available. And running STC is the long pole in this tent. That's the one that takes the longest of these 4 items.
So when you build things parallelly, so where does the artifacts end? Because if you say that every step is taking its own VM, then where the artifacts will end?
They end up back in the original through some mechanism that I don't understand.
Okay.
So they have a way of, you can share the artifacts that were built before. When your build is done, those artifacts appear in whatever was sort of your first workspace, they call it.
Okay.
The pipeliner is doing that. I didn't do anything to make that happen.
Okay.
So they're doing that as part of the plugin, is my assumption. You know, the usual stuff, if any of these steps fail, that's when you'll get an indication like this over here, where this guy with the hashed red and pink says basically, yeah, it died. They do have a log file parser, which attempts to split it up in the 4 sections. So for example, the first thing we run is the unit test. And so here we can see the unit test listing. The second thing is the Java docs. And so here we can see what the Java docs output, et cetera, et cetera, et cetera. The way it does that is surprisingly primitive. Each one of these parallel steps takes that name that we gave it over here. It takes this name, unit test, Java docs, Docker images, and just anything that comes from standard output from that job has open bracket, that name, close bracket as a tag. And so they have a very simple parser to pull that out. So, you know, that in a nutshell is the pipeline. Like I said, I don't like the script at all. I think it's way too verbose. I think we can fix a lot of these problems. But we sort of had this meta problem of whenever I ran this thing, it broke Jenkins. And so we just kind of stopped looking at it after that. We don't know if it's something in the way we have Jenkins configured. We don't know if it's something in my script. But we couldn't have Jenkins dying all the time. The secondary problem was this business of copying everything causes it to use a tremendous amount of disk space. Because basically we download all these artifacts to build ONOS, and then when we build these steps, now we copy that 3 more times. So the buck outs are huge, and now we have 4x the space. Maybe there's a way to make that shared. I don't know. So my idea with this, if we go back to here, the pipeliner is at its core, it wants to be a DevOps kind of tool. So what it really wants to have is, yeah, go ahead.
Yeah, I was thinking, what is the purpose of building Docker images every time there is a Jenkins job?
We'll get to that in a minute.
Okay.
So basically, the idea was in what you want to have, so sort of to the right of this, after your post actions, you want to have a step that says, wait for external input to tell you to deploy this somewhere. That's kind of what Pipeliner is for. It really wants you to be able to push a button, literally push a button that says, I like this build, deploy it as my release build. So that's why we started fooling around with it. The couple of problems with that. One is we don't really have any infrastructure to deploy it to. We haven't set up VMs and stuff. We talked about setting it up on the Office network here. There's a bunch of things we tried. The other more sort of fundamental problem is because we're using Java and because we're using Buck and because we're using POM files, the actual version string is burned into the software you produce. So you have to know ahead of time that you're producing release 1.0. You can't do that after the fact. I think there are probably schemes to make that work, but that would require changes to the rest of the build that I just wasn't willing to do at this point. So to answer your question, basically the intention was, right now the way we do a build is one of Thomas, Brian, or myself pulls the source down onto our laptop into a separate repo, runs a whole bunch of scripts. You saw them. Did you go through that yet? We haven't been through those yet, so we'll see that later or tomorrow. Runs through a whole bunch of scripts that do a whole bunch of things, build a Docker image, do all this stuff, and then at the very end publishes it. And I very much wanted that functionality to be here in this pipeline rather than being run on my laptop, so that I could just say, do the build and I'll go look at it when it's done. I don't have to worry about nursemaiding it and that sort of thing. So I hope that answers your question of what the intention was. It so far has not proven at least to my ability to use it to be able to do that.
So making a Docker image is just a post-build step.
Yes, exactly. And it runs in less time than it takes STC to run, so it's basically just consuming cycles. It's not really causing the builds to be any slower. The guys who do Cord are at least were very enamored of this tool. Their build is quite a bit more complicated. They do things like deploy the build bits to known locations and then run acceptance tests on real hardware and things of that nature, which we just don't have that right now for ONOS. But that would be something that would be cool to do if we had the lab space for it, which we currently don't. So that's kind of the primer on sort of Pipeliner. Were there specific things you wanted to talk about?
Well, like, what do you think the scope of this brigade would be with respect to this Jenkins? Like converting, I mean, from Brain, I understood that you have 2 build jobs out there in Jenkins. One is on the get it patch set, like whenever someone is uploading their code, there'll be one Jenkins job, and then probably you have one on the nightly build.
So this is the nightly, what we just went through. There's no reason to build a Docker image every time you do a check-in, for example. Questionable whether you would run JavaDoc every time. Well, I think we only run JavaDoc on the nightly currently.
No, we do.
We do run it every time.
Yeah,
okay.
We want failures in JavaDoc to get
okay.
check-in.
So as part of peer release, what is it you are actually expecting? What work should be done with respect to this part?
So my goal in the previous release, which didn't happen, was to have 2 pipeline jobs, one to do the nightly build and one to do the Jenkins triggered build. And that's just have what everybody used, including using the STC smoke test. We made some pretty good progress on the STC front. I implemented this stuff and it was looking great, and then the wheels fell off. I don't really know what happened. So I think from the Brigade perspective, you can take that script and run with it. That will do essentially what a nightly build would do. It could use some work, but it will function the way it is. I guess my hope would be that we'd get a lot more experience with the pipeliner itself in terms of, did I write this the correct way? You know, is there a way to limit the resources it consumes? What execution model should we use? Most of the examples that I saw online use these pipeliners to assign work to known entities. So for example, the Docker build is a good example. You would just have a VM sitting out there that did nothing but your Docker build. And what this job would do is just tickle him and say, hey, build this, and then not worry about it anymore. We're currently running all of this stuff on the Jenkins execution threads, along with everything else that Jenkins is doing. So that's part of the problem too, is we're just overtaxing that resource that we have there. Maybe there are some things you guys could do with VMs, containers, I don't know what, to actually assign, like, this is your build module, this is your STC test module, and assign the work to those guys. That way you get much nicer separation of powers, and you don't have this problem of all the resources of Jenkins being chewed up by this one job, because the individual, what do they call this? They don't call them, do they call them executors? If they're off-world, yeah, slaves, yeah.
Well, so I mean, the other thing, right, is that this is just sort of the quote-unquote nightly, or the one that runs periodically. There's other jobs that run, like the Sonar code coverage stuff, which we could run nightly. I don't know if we want to see. So the thing is, what would be nice from my perspective is if there were these common building blocks, right? The building block is used by the Garrett job, the master job, the Sonar job, kind of everyone needs to build, right? The test job is going to be used by the master job and the Garrett job. Something like the Sonar coverage reports, I mean, they could be run by the master job. Maybe only upload them if you're publishing the release on like a nightly basis. So maybe we run it 12 times a day and only publish it once. The Sonar analysis step, maybe we skip and only do the static analysis, once a day because it's kind of expensive. So that's something that I'd be interested kind of in learning more about is, how easy it is to define multiple of these pipelines for a single project, and then how one goes about like pulling them together.
And I don't know if you need to. The examples online are so typical of this kind of a thing. They're either ridiculously simple hello world things, which you could just like read the UI and make that work, or hideously complicated Groovy stuff that just doesn't make sense. So there's got to be a way to share code, right? There's got to be a way of those steps that I showed you, making those a Groovy script somewhere. So like Brian said, you could have multiple Jenkins jobs that refer to that same code. It's got to be. Otherwise, what's the point of doing it? So that's, there's it's a lot of investigation still of how the pipeliner works, what the best practices are. There are some blog posts and things about, the 10 things you need to be doing with pipeliner. Like one of them was amazing. I just kind of think like we need a strategy of where we want to go, basically. What can this tool actually do for us? That's why I stood up this prototype, because I wanted to see what it was actually doing, and it wasn't behaving the way I thought it would at all. So it was useful, but we do have this problem where it's just really expensive on resources, and I don't know again if there's something we can do to make like that space shared. I don't know.
I have a question here.
Sure, go ahead.
Yeah, can you go on the root of Jenkins to display all the jobs?
Yeah.
Freestyle. Yes. So I'm wondering if all of these jobs are related, and if yes, are we going to transform all of these freestyle jobs into a pipeline?
I think ideally, yes, but in reality, stuff like the Loxy is executed so infrequently that I don't think it's worth spending a lot of cycles on making that work, as an example.
Yeah, so I guess maybe we could break these up into, dashboards or views at the top, right? Like,
yeah, there's these, you can actually apply categories to them.
Some of these, like the ONOS Loxy, Garrett, the copycat one, these are sort of upstream project dependencies that we have or had maintained our own forks of. Now copycat, we're using the upstream version, so we no longer need that job. The ONOS Loxy stuff we will periodically run, so we do periodically need to access that. But that's kind of like, okay, freestyle job, whatever. And then there's a lot that kind of are jobs that are more or less clones of the others that are more for experimentation. Like, for example, you have ONOS Garrett Buck, ONOS Garrett Maven, ONOS Garrett with STC. At this point, we've more or less deprecated Maven as our build tool.
Right.
So we've given it the appropriate amount of time, and we could probably get rid of that job. The Garrett and Garrett with STC and Garrett Buck and Garrett, all these, right, could probably be more or less consolidated. And there's a lot of kind of crap that kind of got built into these jobs over time because, we changed the way things were done from one branch to another. Perhaps we should have named these jobs like Garrett dash, 1.9 plus or 1.8 less than or something. But yeah, there's more jobs here than actually functionality really. And yeah, more or less it's a nightly job, sonar runner, a master one that will periodically run and publish. Well, I guess periodically run. I don't know exactly the difference between master and the Garrett-based ones, but
yes, I don't remember what the differences are either. Master runs a different set of builds. Like for example, the Yang tools is a separate repo that is using our Jenkins because ONOS uses this functionality. But this is outside the scope of anything that the build brigade is doing because it's not ONOS code. It's owned by other people. So like that, we wouldn't do anything with. Similar with ONOS UI, similar thing. We package and ship those artifacts, but we don't actually, they're not part of ONOS. They're a separate thing.
Well, UI is already more part of ONOS than Yang tools.
That's true. I guess we do build it as part of our sort of production release build, right? So
assuming the code segregation is in place, so are we looking for having the similar kind of build jobs tied to each workspace?
that I don't know. I think my naive understanding of how the code splitting would work, you would just have in here. So instead of having one build, you'd have like dozens of builds, right? You would build core, then net, then this and that, and they'd all be kind of as separated things.
I think the idea would be more that we use like a tool like Repo to download the entire workspace.
Okay.
But that's on the release build.
No, on the verification builds too. So you make a change on one of the sub projects, we check out everything. And then, yeah, we check out everything and then we run the complete build, make sure that it passes and move on. I mean, it's possible for the Garrett validations we could, well, yeah, this is where things get kind of complicated, right? Yeah. Because it's a symbolic link between projects. And so theoretically, retriggering the same Garrett build 3 times could result in 3 different results if master on a dependent project is moved. So this is probably the biggest challenge for me is how do you link these things together in a way that produces deterministic results? And maybe you just don't care. I don't know, but because either you check everything out and you build it, and then you retrigger the job and you get different bits if the code bases have moved ahead. So it's possible that like when the Garrett trigger runs, it works, and then someone checks something in that breaks everything, and then you go to merge it, and on merge, dependencies change, and now when someone else does a pull, you have a broken build.
Okay.
So I don't.
That's actually very different than how I thought it was going to work. I thought what was going to happen was like, say, core is a separate depot that gets built, and then those artifacts get positioned somewhere, and then the next stage of the build uses the artifacts and ignores that the source even existed. But it doesn't sound like that's the model.
I don't know. You could build it that way too, but you have the same problem, right?
It gets hideously complicated. We have a lot of dependencies.
I mean, we're looking at, in the ONOS code base right now, there's like 180 different modules, right?
Yeah,
and there's a pretty intricate graph of dependencies between them.
Yeah. To run Thomas's tool to generate the circle with all the connections. Yeah, I agree.
So I don't know. I don't know what we want to do, right? Do you want to, before you can click them, like as part of the merge process, do you want to run, one final little sanity build to make sure that it's gonna go in cleanly?
So the issue is that if someone, we have this issue today, right? Someone can make a change that's incompatible.
Yeah, but the thing is, the changes go in atomically. Yeah.
Oh, because it's a single Git resource. Yeah.
Yeah, you can do a rebase against a single tree, and then
we can enforce it during the commit process.
Yeah, you can require that rebases occur.
So how is it in the disaggregated model? Does rebase all of them, or just the one you're working on?
Just the one you're working on.
No.
Sorry. The rebase tool will rebase all of them.
Okay.
But from a actual Git perspective, the other ones will get fast forwarded and yours will get rebased. But nothing prevents those other branches that aren't yours from moving ahead or not.
Because they are on their own path.
Right.
It's almost like you need to know what the state of the world was in terms of the heads.
It's like we want
the heads
the
on all your
complexity
repos.
of Git as well as the flexibility of Repo.
Or you just say, whatever, who cares? If it breaks, it breaks, and the master build will pick that up, and there's only a few commits that could have gone in, every 15 minutes or something, and someone's got to stop and fix it. But the question, or the problem with that approach is usually the people who have to stop and fix it are core for maintainers and not the people who actually did the code.
Because they won't see it. Yeah, exactly.
So to take a step back, what sort of when somebody checks in code, what acceptance testing is done on it?
Right now or in the future?
Well, but I guess both.
Okay, so right now, when you hit Garrett with a review, that tickles Jenkins, and Jenkins pulls your branch. You have a special branch just for you. That gets pulled, and ONOS is built. The unit tests are run. Check style is run. We think JavaDoc is run. And then you get a thumbs up or a thumbs down based on all of that. We want to add the STC run to that as well. That's sort of orthogonal to the pipeliner business. But that would basically be running a acceptance smoke test kind of thing on whatever patch you submitted. The reason to do that is we have had way too many DOA builds because people check things in where, like, you know.
The unit test passed, but they messed up some config or introduced a dependency cycle or something where
the OSGI stuff doesn't work because they didn't put an explicit dependency in something they need at runtime. There's many scenarios that you can only find if you run Carap, and that's kind of what STC is for. Yep.
So
that answers the question.
Okay, yeah, that does answer the question. I guess so if that's going to get run, the debate is whether the pipeline helps that, or maybe I'm.
So I think there's kind of two discussions going on, unfortunately. We started out in pipeline, and then we started talking a bit about the disaggregation and how basically how you can protect what should become your master against incompatible changes in multiple different repos. I think that's kind of what Brian's worried about.
Yeah, there's not really...
Whether you have a freestyle job or a pipeline job that's doing that verification is an orthogonal question.
Yeah.
Right.
You should definitely have something that at the very end says, you know, does this all hang together?
Right.
And that could be either one of these.
So
the
what
idea with pipeline is it should be faster. That was another reason to look at it, because it is executing things in parallel, and we didn't really want the Jenkins check-in jobs to take 15 minutes. But
is it possible to? Yeah, I realize that the speed is of the essence when things are going to get accepted. One other thing that which of those components is likely to fail? I'm assuming that the JavaDocs one is probably not likely to fail.
It does sometimes, but yes, it's much. The one that's going to fail is either the build is broken, which is the build step, or one of the unit tests will fail. I don't know. We still have people checking code that breaks unit tests. I don't really know how that happens, but
or check style.
Check style, yes, that happens a lot actually, because people forget to run.
Can check style is that how quickly do those other things run?
So the way it's set up right now, the unit tests, JavaDoc, and check style are all run as part of buck test, which takes what, 5 minutes to run it from scratch?
Maybe less.
No, the whole build takes 5 minutes.
Yeah. If you hover over one of these things, right? This one, for example, logs.
The top one is yeah. So all the tests and everything. It's like 3.5 minutes.
Okay.
We can actually go up to here.
Well, no, is it even faster? Well, so the thing is, Garrett, Buck is smart enough that if the code or its dependencies haven't changed, it doesn't have to rerun the unit test.
Right.
Right.
It only runs the ones that are effective.
So I think theoretically it's possible that the no-op sort of Buck retest takes about like under 10 seconds. For unit tests, check style, the JavaDoc. I mean, the whole point of Buck is that if nothing changes, you don't have to rerun everything.
Okay. I guess I guess what I was trying to get at is if you have things that are a low bar, if you stick them early in the acceptance process, so like the check style, especially if you have these app repos that have almost nothing in them or have much less than the full. So you might want to run the check style just against the couple of files that are checked in that other partial app specific repo. And then maybe not run it on the code base as a whole, but have that run as when you guys do your nightlies, and that would be easy.
Go ahead. Sorry.
Yeah, and that would be an easy first weed out step before you do the more expensive steps.
So in theory, that's how it works today. As Brian was saying, basically what happens is Buck is super smart about what was changed and what depends on what. So
right.
For example, if you change one file in an app, the only check style you're going to run is the check style on that directory.
Oh, okay. It doesn't. I thought it did everything. So yeah, that's smarter than I thought it was.
Yeah, as long as the cache is enabled.
Well, yeah, exactly.
Because if you don't enable the cache, the result.
Well, I mean, yeah, it's stupid to run Buck without a cache.
Yeah.
The only reason you run Buck without a cache right now is because some of the plugins just generate results that are non-deterministic, right? That's a bug, but I mean, yeah.
You have a flight, but you don't fly.
Yeah, exactly.
It's more like you solve some complicated equation, you have the solution, and then you throw the solution out rather than just like reusing the app. But yeah, I mean, okay, yes, agreed. It may only make sense when you use the cache, but you should be using the cache.
The issue of documentation. Suppose there is a team which writes documentation. Is documentation linked to Jenkins or it's a separate thing?
I think right now it's Javadoc is generated off the sources, so that's totally linked into here. The wiki is completely separate. That's separate tools, separate acceptance criteria. Everything is separate. It's not under. It's under a different source code management system. I don't know about like Google Books. Gitbooks. Sorry, yeah. How that would, if that stuff is that's checked in, right? So that would be part of this process. Yeah.
If at all we choose Gitbook.
Okay.
Yeah. So if we go to some model where the documentation is sort of processed off of things that are checked into the source tree, then they would absolutely be done as part of the Jenkins jobs.
Yeah, but in that case, I'm wondering how they will be, like for the codes, it's possible, for example, to check, Jenkins is able to check whether the code does not comply with the requirements. But what about documentation? How will Jenkins do it automatically, for example?
So when you're referring to documentation, so what exactly you're referring, Alex? It's on the Javadoc or it's on like quick start or how to get started kind of documentation?
Yes, it might be Javadoc, but also it might be the documentation coming from, for example, the teaching brigade. I don't know whether all the work of these the works of all brigades will be, let's say, linked to the this pipeline of Jenkins.
Right,
I'm talking about all the Docker, in fact.
What do you? Sorry, what validation are you trying to tease out here?
Like, I'm thinking in the teaching brigade, we will have to write some documentations, and so we'll have to review them, which will take time. And is there any way to accelerate this job through Jenkins? That is one. That can be one part, but also the other part can be Javadoc.
Well, so I mean, yes. If there are automated steps, for example, like if for example you're using Gitbooks or something, and there's some binary that's run, and there are errors or exceptions that are thrown if your markdown format's incompatible. If you wanted to run like some tool that was a spell checker, I mean, anything that you could run on your laptop to validate the documentation could theoretically be run on the documentation as part of the build validation process.
But here's the thing, right? if I understood the scope of teaching Brigade correctly, they are targeting to produce a coursework with respect to the difficulty levels of the readers, say something like beginner, intermediate, advanced. Like they are not actually trying, because ONOS is just a part of the entire scope of teaching Brigade. They actually start with SDN basics, networking basics. They even talk about VMs and CORD. So if I understand their scope correctly, their scope is just to provide a coursework in order to get the networking and networking concepts and ONOS concepts in a specified format so it can be consumed. But the documentation that we are talking here is actually twofold. One is on the implementation specific. Suppose that today I'm writing a feature and I want to document this is how a feature should be turned on, turned off, and then I can have a design documentation explaining this is how I implemented this feature, and then I can have a Java doc that actually takes me through the list of classes, the list of interface that is available. So that can be automated using Jenkins, and the how-to doc or this is how the feature should be turned on, turned off kind of doc will be part of wiki. So that may not necessarily come under Jenkins role.
I mean, but yeah, I mean, fundamentally Jenkins runs stuff in an automated way and produces a vote. If things pass, then it says yes, and if things fail, it says no. It doesn't mean that the code does not need to be human.
You could pretty much use Jenkins to do anything that can be automated.
Sure. It's just
Yeah, exactly.
So
It
I mean,
saves a lot of files, yeah.
Alexis, the answer to your question is yes. I mean, if there are automated steps to verifying documentation that gets checked into Git repos, you can use Jenkins to verify it.
Right, but it doesn't necessarily come under this Brigade, right? That particular.
It would if they come up with something that requires building or deploying.
Let's say we decided to do the architecture or system level documentation in Git books. It's checked into the source code alongside the Java code.
Okay.
Then it would probably make sense to have, as part of verification, I don't know, you could do simple sanity checks. Does there exist a Git book chapter for every directory of source tree? If not, fail the job and return an error that says documentation missing.
Okay.
If you wanted to do, I don't know, spell checking, or you wanted to do checking that, the files are not empty. I mean, these sort of basic gating checks to be done by Jenkins if you wanted them to be done.
My suggestion would be, before looking at broadening the scope of the Brigade, I mean, I completely agree with what Brian said, but before looking for broadening the scope of the Brigade, focus on the things that are close into GitHub first, before seeing what we could do. Pretty soon you're going to be,
So I guess we kind of got off topic a bit. The broad question I think that needs to potentially be answered, and then I'm partially to blame here, but it's how do we gate check-ins, protect master, protect sort of the quote unquote master, the multi-repo master from conflicting incompatible changes across different repos. So that's an open question. We can come back to that later. Do we want to try to come back to pipeline and maybe do a demo of how a pipeline job gets created on Jenkins 2? And just try running it?
Yeah, we can do that. Yeah.
Just because I think, it might be helpful
for
people to
So I can show you what the...
I want your help in actually freezing the work item for case release, because my understanding was the pipeline itself was not available, but right now I can see one working version, so I'm not sure what should be targeted for case.
So obsolescence of phone calls.
Yeah, Jenkins bucket.
So I think
bucket, to me, that's completely something that doesn't need to be partially released. It's something that can happen anywhere along the line, right? Before or after. Something.
Well, so the thing is, the Build Brigade charter has like 4 or 5 different areas or opportunities, right? And so what we're trying to do is we're trying to produce sort of the next set of action item steps, which will translate into JIRA tickets across all of those areas, right? And so your top priority might be the POM obsolescence, right? But there's still other areas that the Brigade charter covers. And we'd like to, with each of these areas, right, be able to identify a concrete next set of steps to kind of make progress in those areas. So I don't know what those action items are yet.
Sure, but I mean, to me, doing this or doing, for example, the experiment with code disaggregation, that's something that can happen completely independent of K release. And as a matter of fact, it probably should not be something that happens as part of the K release. It can happen in a K release timeframe, but it's not really something that rolls into the K release or is going to be manifested in the K release. Obsolescence of the POM files, on the other hand, is something that manifests itself in the K release.
Okay.
And the bits that are actually tagged and it's in the repository saying there's no POM files as of. Anyway, that's kind of where I'm coming from. So I'm definitely completely agree. We can be doing more than one thing at the same time, and we should be. But to me, this is not something that needs to answer your question specifically. You can do that tomorrow, but it's still not part of the K release.
Okay, so let me just rephrase my question. So, what should be the next step or next workable item that we could target as part of Jenkins? I mean, taking your script and trying to understand why it doesn't work or trying to extend that.
Well, so I don't yet know what the action item is. I mean, I'd be interested in kind of seeing. Yeah, I think broadly speaking, you know, Ray put together a prototype, making that prototype work and figuring out if it's a good model, and then kind of adding pieces to it to do other things makes sense to me. But yeah, I mean, I'd sort of be interested in kind of, I don't know. Yeah, sure. I don't know, right? Like, I'd be interested in kind of like seeing what it takes to pull this in, like starting sort of the process, right? Because, you know, we could say that the action item is, you know, import the pipeline job into Jenkins, right? And we could, maybe that's a 1 second thing that we do right now, or maybe that's where we start. I don't know.
Okay.
Right? We'll need to figure out with the multi-repo thing how to answer that other question too, right? And it's an open question, right? That's not like do this thing, right? It's like figure out how this would work in this mode, right?
Okay. And if Alexis is interested in working some items on a Jenkins bucket, so I'm just trying to help him to choose what should be the next immediate item that he could work on.
Well, so I mean, there's opportunities are right, like clean up jobs, old jobs that you know may not be required anymore. One is take what Ray started as a model and try to produce, you know, pipeline jobs for these things, or try one pipeline job and see how well it works. I mean, from my perspective, I mean, I still haven't had any really working experience with pipeline. Ray has had some, and there's been some pros and some cons, right? So, I mean, I'm personally not sold on pipeline per se. I'm willing to be sort of sold on it, but it's hard for me to say. I mean, the next step, I think, largely is like figure out, you know, how this thing works, if it works in our context, and what the proper modes of use are. I mean, another opportunity is, you know, spin up slaves rather than running all the Jenkins jobs on the same
master
controller, right? So I think that the high level point here is, you know, this CI thing sort of it sort of evolved organically based on some small scripts, and at that point freestyle jobs kind of made sense. Pipeline didn't exist yet, right? And so the question is, what's the next step in terms of evolution here? And there's a lot of different ways you could try to take it. But I don't know. I mean, yeah, I personally haven't gotten to a point where I have any concrete, really, action items.
Yeah.
It seems like this is sort of more of an exploratory effort. Just like with Git books, we don't have any action items, right? With Git books, it's like figure out what people's skill sets are and whether or not this is a good working model, right? I think it's sort of the same thing here. And I don't know, maybe we could spend a little bit more time trying to just get a feel for how a pipeline job can get invoked, how it gets imported, that kind of stuff. And maybe from that we'll be able to
figure something.
Sorry?
You'll be able to deduce something.
Yeah, maybe, I don't know.
There's a higher level question too, which is, you know, we kind of hit on this as we were going through this. Is pipeline even the right tool? We literally picked it up because the core team was using it. I don't know if that's right for us. I really don't.
I don't see anything wrong with it. I mean, we need to be able to do things, and there's building blocks, right? Yes. So to me, it's a reasonable way to string it together. I mean, unless we have something that's obviously better.
or you want to switch completely the sort of the build invocator,
And the
Travis or something else.
And the having the Jenkins job checked in the code model is far superior to the other way. So
I suggest we just proceed with it, and then as we, that's something that we can, something that we're working with. We're working with Jenkins. This is an evolution of working a little smarter with Jenkins, and as we establish ourselves, the Brigade establishes itself, it can then make other choices. Unless right now, obviously, using Travis right here would provide these and these and these and these benefits right now, and let's do that, that's fine. But if you don't have that, I would suggest we don't go out investigating. We just proceed with this, and then as we get oriented, we can investigate.
Okay.
I'm really interested. I'm just encouraged, focus, and make progress. I want to make sure we don't get 5 miles wide front and move 1 inch deep, and keep inching very slowly forward. So then prefer making deeper thrusts in certain territories.
okay, so then to me the obvious first sort of quote unquote action item is take this script and run with it on the new Jenkins.
Okay.
See what you discover.
Yeah.
Maybe all the performance problems that I had just go away because you have more up-to-date software. I really don't know.
Okay.
So that would be a good thing to start with.
Okay.
That's what I would recommend.
Refactor that script as you see fit and just run with it.
Okay. So Alex, is like you would take that up, right? Hello?
Well, yes, I understand, but I still have one question. For example, is there any kind of flow chart, for example, when when a developer commits a code, how what is the first step? We have a lot of servers, like we have Jenkins sonars, we have Gerrit, there is a lot of these build process. There are a lot of steps which are done after the commit of the code. So having that, for example, in specific way, I think will help us to know what you can include in the pipeline. For example, if there was something. Yes, go ahead.
And I suggest narrowing it down, right? So we have number of jobs that you saw on a sort of a list of the Jenkins. So some of these jobs are sort of, we can think of them as ancillary builds, right? Primary focus should be on providing validation builds for Gerrit, effectively to be able to, it's a build that can give thumbs up or thumbs down to a certain patch set. And so the things that we include in that validation today is the compilation itself, compilation of unit tests, execution of unit tests, execution of the check style validation, which happens under the umbrella of tests, production of the Java docs and validation that they are clean. Am I missing something?
Docker is piece.
Okay, and so then, and there is two sort of tail end jobs, which include the SDC, which is effectively a system level test, basic ignition test, does it blend, and a Docker packaging. And so, frankly, I'm not even sure why the Docker should be hooked to the validation autonomy.
It should only be for the nightly.
Okay, so
that was the intention.
Forget about the Docker, right? Yeah. But we want to, so I think the focus should be to make sure we produce a pipeline or so efficient validation run. And the reason I say efficient is because there's a lot of room for opportunity to parallelize things in here. At least in two potentially 3 different strands of execution. For example, the Java docs, the unit tests, and the system tests can all happen in parallel after the build has done. So I would focus on producing and pipeline is something that would allow us to do that in parallel. So I would suggest in focusing on producing a single pipeline definition for a job that can provide the validation.
Sure.
If we establish that, then they'll first of all get the team oriented with it. They accomplish something that runs all the time. So this is having efficiency in this area is going to be extremely important, because that will give us very, very timely thumbs up, thumbs down from Jenkins on a patch set.
Look at it right now.
That's something that runs all the time. Exactly. The sonar, master, all of those things, they're not causing us really that much of a pain. We can run with the existing ones. Now, I'm not saying that they shouldn't be revisited. Yes, they should, but that's not where we should start. Yeah. We should start with Gerrit validation that's efficient, comprehensive, and once we get that done, then we can move on to the other territories. Documentation, master, validation periodically, nightly sonar, whatnot. Those can be then added to the list, but Gerrit validation should be first on the list in my view.
I agree.
Okay, so there's an action item for you. Take the existing pipeline script that we have, figure out how to make it work without trashing the Jenkins instance, and plug it into the Gerrit validation build.
Take out the Docker part, and then see how efficient you can make what's remaining.
I'll take a full copy of this one.
What do you want me to add?
This action item.
Which one?
What are you doing?
I just said these two things, right? Make it work and...
Yeah, but we have specific action items converting the script into our cover one.
Okay. Refactor, raise script as required, drop the Docker part. Yeah. And then these are just like backlog items. Yeah. Figuring out how to share building blocks, move the executors to slaves if resource isolation becomes a problem. And then the other open question around how do we gate check-ins or protect master in repo model is sort of a shared Jenkins / repo problem that we can revisit later, right? It's not an immediate term thing, because currently the whole thing's going to be just checking out the main source tree anyway.
Okay. I think I'm good, so you can proceed, right?
And so what was the plan? Is to do the demo of that now, or was it something that would be taken offline? I wasn't sure. We talked a little bit about both, right? And I want to make sure which one is the point.
I think would be offline.
I mean, we have a new Jenkins system set up. I don't know how difficult it would be to just plug it in and try it against a master build.
So because before I walked out of the room, we were talking about maybe discussing doing it right now.
Yeah.
And I think that's what you were just alluding with your last comment too, right?
Yeah. So,
and then, but we also talked about before your last comment, there was also sort of implication that Vishwa and Alex or whoever would run with it on their own offline. Which do we want to do?
I think he was about to start the demo, but then I want to face the action item before we.
I see. So let's.
Well, I was just going to show you what I had to configure on the existing one. It's basically like two things, right? It's here's how you fetch my bits, and then you want to check the mode to by Jenkins file, and what that does is that looks up the file name, Jenkins file, in the root of what it just pulled, and it runs it. It does some pre-processing on the Git repo to know, for example, which branches you have. Like, for example, if you go up here under ONOS pipeline build, you'll see this master. Well, that's because Jenkins file is only in master. But I'm assuming if you had it in multiple branches, that it would create multiple jobs, one for each branch.
Could you show us how it actually checks out the exact branch that we are actually posting in the cart section?
It doesn't do that right now. You'd have to figure out how to do that. This is the nightly build. So this just says, get me top of master and let me run with it. It's not hooked into Jenkins, Gerrit at all.
Right, but today you have a validation.
Oh, for the one that exists today, sure, we can look at that. There's some, you were saying there's like events that get streamed off or something.
So when you tell Jenkins that the Git repo is like a Gerrit-based one, and then you tell it that the trigger to start the job is a Gerrit trigger, Jenkins uses SSH to attach to the server, and then streams the events in. And the events that get streamed in are like patch set created, draft, publish, merge, whatever that come through. And Garrett can be configured to listen to that.
So as part of patch set creation event, you'll be having the branch tag, which you'll check out.
Yeah, so in the patch set created event, there's going to be a whole bunch of sort of environment variables that are going to be created. And so, I mean, we can do the demo again like we had yesterday, and all those environment variables are going to be available at the time of. I'll show you. Just so I'm going to take screen sharing back if you don't mind, right?
Go for it.
All right. So, we said you can do SSH. Garrett stream events.
Yeah.
So this is effectively what Jenkins is going to do. And then if we go over here, we had a patch set that I created yesterday somewhere.
Oh, and you just do the UI?
Just do the UI. And so if I were to now rebase this patch set, what you'll see is you'll see there were two events. The first event, maybe I'll pull this into a linter, just so that we can do it better.
Oh, yes.
So we got two events. The first event had some information about the submitter. That's me. This is a ref updated event, which is not the one we're triggering on, but it says the old reference, new reference, ref name, whatever. In this case, we created a new reference because it's a new patch set. We'll also note that there's another. This box a little, but there's a patch set created event as well that's going to show, and it'll tell us the change key, the base ref name, the project is ONOS. The change has some information about the change. The patch set information, we get the revision number, its parent, its ref tag, etc. So all this information is getting streamed to Garrett. Now, or sorry, streamed from Garrett to Jenkins. So now if we go to Jenkins, is this the one that's triggering?
Probably. No, no.
Different one. Maybe I already finished. Who knows? Jenkins. All right. So my patch was called 3666.
3626.
36. Oh, it's a trivial rebase, so it's not going to run again. But if we change some code, it would force a rerun.
Oh.
But let's do that just so that we can have some. We'll change the most important file and delete a few of these lines, whatever. See ya. Publish edit. We get more streamed events here. And we're going to just make sure this doesn't get merged. Now, if we look over here at our jobs, we should get getting a whole stream of stuff. We should get another job. Not sure why it's not coming through, but whatever. We'll deal with that problem later. With one of these jobs, there's a bunch of these parameters that get extracted from the JSON. And so this is sort of the same stuff we were looking at in the JSON. And these are literally bash variables that you can use. So if you want to like send an email to someone, you can say Garrett change owner email or something, right? And then when the build actually starts running, we can look at the full log and see, well, it does a clone, it sets the remote URI, it fetches the changes, then it fetches the specific reference that it was targeted to check out. So all this checkout part is happening automatically by the source control management system. Okay. And the Garrett plugin knows how to both parse the JSON and also fetch references appropriately. So you don't have to worry about checking out the code per se, right? You're going to get a cleaned workspace to work with that's going to be checked out to the branch that has been specified by the Garrett concept.
It's just effectively from there where the pipeline starts.
Right,
So
and that's also where the freestyle job starts for that matter.
So in the pipeline
I'm just, yes.
that I created, there's an initial section that does a fetch of the tree. You wouldn't do that.
Yeah, so in this job, right,
So if you want to create some jobs and play with it, do you have access to this?
You should.
So this would be on Jenkins too, right?
Yeah.
yeah, so there's the new Jenkins that I just created. We can give people admin access to it. I mean, if you specifically want it, we can do that.
So, and also, just, you know, clearly the objective should be to get to an efficient and comprehensive validation build. But if an intermediate step is to just produce a build that builds a master in the same way you would build the validation, that's perfectly fine. And that's effectively what Ray's job was doing. It was basically saying, you know what, rather than with all of the rest stuff for now, we're just going to anchor it on master and we're going to run it nightly. But to work out all of the kinks with pipeline, with SDC and everything else. That's sort of an intermediate point. And then once that's working and once we know we can reserve ourselves, okay, and the Warden stuff, because this will touch on the Warden stuff also, right? And SDC stuff.
The main
Once
reason
that is working, then we can, you know, basically use the same definition and just surround it by just basically different preamble.
Okay.
Saying instead of just checking, instead of pointing in master, we're going to be triggering it of these rest.
The main reason that I liked playing with the nightly as a model was because
It doesn't mess or affect anything.
well, it's also really easy to trigger. You can just trigger it manually.
Just
Whereas
exactly.
if you want to do an off a ref, then you got to tell it fetch this thing, and it just becomes a pain in the butt. It's much easier when you just say fetch master and build it.
Yeah. So if you need to do, you know, if you guys need to do that, I would start probably there. And then once you work out all of the kinks with that, then just hooking it up to the essentially the Garrett workflow should be fine.
Okay.
But you know, certainly take out the Docker build, for example.
Yeah, I would.
You're going to be missing a lot of junk on that machine, and you just don't get involved with it. Just skip it. Just remove it.
It's easy enough to add later.
Yep.
Right?
We already have the code, right? So
Exactly. Yeah. And it's just a bit of a JSON.
Yep.
So what I just did while you guys were chatting was I just created a job on Jenkins 2. I pointed it at the ONOS project master.
Is that a free form?
Manually triggered pipeline job.
Oh,
Pipeline. So it should now find the Jenkins file, parse it, and then generate the steps.
So it's failed now, right? But now you have something to start with
Yep.
and figure out the.
Because I can't find the Warden.
Yeah. So I think strip the Warden stuff out, strip the Docker stuff out, just get a validation job, or just start with a master job. Run master using pipeline, get that working, you know, so you can reliably retrigger it. Then we can turn on the Garrett trigger, right? It's not that hard, right? You go into the configure, and then instead of manually, you just add a build trigger. So if we add I don't think I installed the Garrett plugin, but you install the Garrett plugin, and then okay, there's a build trigger. Okay, you add that. So you know, you can slowly kind of work up, you know, from piece parts. Okay, now it's triggered on the Garrett job instead of just manually triggered. Okay, now it's whatever. I mean, now I add the Docker step, or now I add the SDC verification step, right? But let's try to get that. And then, it turns out that running this thing trashes Jenkins. Okay, so let's figure out how to get this running in isolated resource environment. So I think we can sort of build stuff up from here. But yeah, we can give access to this Jenkins environment to whomever needs it. Should be the same credentials, crowd
Yeah, for
credentials.
now, we just need one machine, right? We can split it to slate stuff later, right?
Yes,
If or when it becomes a problem.
because I'd be curious to know if they will hit the same problems that we hit with the main yard.
Yeah, so this will both do both, you know, build up data strategies, and maybe build up some code-based documentation surrounding it.
There's also a convenient thing for testing where you can create a pipeline job that instead of fetching it out of SCM, you edit it in the UI. That's really good for debugging. So that's pipeline script mode, and you see there the script is down at the bottom. So you would just cut and paste my stuff into there, start editing it. That way you can do a cycle of editing, check in, check out, check in, which is annoying.
So they have a template for me.
Yep.
I think the old credentials work, so
Good.
we are good.
Yeah, I think I just gave everyone who logs into that machine admin, to be honest.
Good.
That works. Whatever.
Don't get too attached to that, Jenkins. We can rebuild it when we want.
Okay. So, yeah, I'll pass the control back to you, Vishwa. I think the next step we have probably is to figure out, there's a few things that I deleted based on stuff we already covered. So there's a few areas we have to fill in potentially. We've got another hour or so today, and then we've got a block of time tomorrow afternoon. And I was wondering whether some of the additional topics that we've talked about wanting to cover are on the right, whether we wanted to slot those in.
So can we pick any one of these?
Is that all for Jenkins?
Excuse me?
I was asking, is that all for Jenkins?
For now, I think so.
Yeah.
I think you guys have a sandbox where you can try out some things and kind of work your way through it.
All right. Thank you. So let you. I'm leaving now. So see you
Okay.
tomorrow.
All right, thank you.
Thank you.
Bye-bye.
Bye.
Okay, bye.
What was on that list? It was FTC, build scripts.
STC, Warden, release scripts, developer, like the tool star bin scripts.
Oh, okay,
So we have this 4 items, so and we have 1 hour to go.
okay. Well, you guys decide. What are you interested in?
We are interested in everything, so which one is okay for you? Probably we can just pick and choose.
I mean, do we want to cover STC? Because that's going to be something that.
Sure. You want to talk about STC, Thomas? Do you want me to
Sure,
go?
I have a slide deck, who's got the? I can be, since you're projecting already, I'll send you email, right?
Okay.
With a link. Well, actually, I can just send you an invite.
Yeah, I was going to say, I think it's protected, so.
No, it's actually, everybody can see it, at least the one that I'm having. So what is your email address?
If you could send to the Brigade, build-infra.
Okay.
Brigade-infra.
I'll send the email. So what is it, build infra? Is it Brigade build infra or what is it?
It's Brigade-infrastructure.
All right, I sent it.
Put the Gmail 30-second wait. Bless
I botched the email address.
Okay. I'm not getting.
I sent it into the build and package directory on Google Drive.
Just put it in the full screen.
present right there.
Okay, so I'll let you go forward. So this is just a high-level oversight. So the idea is basically that this is a framework for just being able to do developer-oriented and sort of debugging and system testing. It supports modular definition of what we refer to as scenarios, and then the scenarios can be composed into bigger scenarios. It also facilitates by basically parallel execution of the different things. So you can actually run things. You can define these sequences that can actually be cloned to work in parallel across different strands. And it works, it's not a replacement for scripting or for other execution. It basically just stitches existing tools together and into this process flow. It's basically a graph that and it coordinates the execution of that graph. And so that's basically built around the existing use of ONOS tools or other tools. Next. So basic usage is just to type in STC, which stands for Scenario Test Coordinator, or you can say STC, which will run by default the smoke scenario, but you can also run individual scenarios if you want. We have other, okay?
Can we use STC even in our own personal laptop?
Sure.
Yes.
Do it all the time.
So it's not like the Warden that only works in your lab.
No, the
So
Warden
it requires having a cell definition.
Cell, yeah, that's a cell definition. I will explain what cell definition is, okay? So this is basically, okay. So the scenarios themselves are defined using XML files. That's basically how you have, and I'll talk more about what they look like. But that's basically using XML is where you define the graph. The definitions are located all under tools test scenarios. Scenarios can import other scenarios. Scenarios comprise of steps. Step is a representation of some executable that is to be invoked. Groups of steps, basically something to put them in a sort of a nested grouping, so that when you create relationship, you can have one group depend on another group rather than individually depending on individual steps. Basically, groups provide a way of encapsulation. Dependencies between steps can be built in, or you actually, when you define the steps, you can say this step requires this other step. So that's how you build a graph. But you can also inject dependencies later. You can say, you know, you have this step and this step. They don't know anything about each other because they're, let's say, these are groups of the different scenarios. But I would like to create this other Uber scenario that actually runs them in this order. So that means this one will not be required by this one. So you can inject them later. And effectively, by doing that, you define the whole overall process flow as a directed basically graph. The next one. So the step is an individual node. It's associated with some sort of executable. Group is a collection of other groups and steps. It's used to provide encapsulation and grouping. Now, group is a form of a step, effectively. It's an inheritance thing. So both groups and step have to have a name that must be unique within the scope of the overall scenario. So we have actually namespacing construct so that, let's say you could define two individual scenarios which can actually have defined the same step within them. But if you were to then include them, put them together, then you would have a name collision. But when you do the import, you can actually specify namespace so that then you can sort of saying, you know, nest this into some other namespace and it'll all link together correctly. Okay. So the steps and groups can explicitly define requirements via the requires attribute, and they can also be optional. You can specify there can be an attribute that says if this or unless this. Okay, next. So then we have also notion of properties and environments, so that we can actually a lot of the definition of the steps can have the kind of Maven style property expansion. But we can also actually, we can have steps return values into the environment to downstream steps, basically where you have this step can actually return some output in form of a key value that will be then exported into the subsequent environment. Okay, I'm not. Yeah, these are just some details. I can skip over those. I just want to go over the high level picture. Okay, next. So yeah, so the parallel chain. So basically, you can define sort of a sequence of steps, and then you can repeat it in parallel. Basically, you can repeat subgraphs. And so we use this for example, to be able to define, let's say we define a ignition sequence for a single node in a cluster, and then we can repeat it for every node in the cluster. So that when we define a scenario, the scenario is completely independent of the fact that it's running on 1, 3, 5, 13, or 21. Doesn't matter, right? The same scenario definition remains the same, but the steps themselves will actually, the width of the graph will grow, because as the
they work on the same environment, or they have their own sandbox kind of environment. The steps.
So remember, the step is just a representation of something to be run. Okay, so let's say we have a representation for installing, for pushing the bits to ONOS node. Let's say we have a setup sequence, right, which involves making sure we have the bits uploaded. Or even better, we have, if there is any previous bits on that machine, be completely torn down, and the installation needs to be wiped out. Bits need to be pushed there, and the new bits need to be unloaded and unpacked, and then they need to be ignited, and then we need to wait for that instance to come up, make sure that on that instance there's no errors before we declare everything done. There's no reason to be doing that for instance 1 sequentially, right? So we can do all of these things completely in parallel for all, let's say, 5 nodes in a cluster. So this basically builds a process graph, and the coordinator just simply makes sure that the requirements are met. It starts the next step. Basically, it pours the paint through the graph. Effectively, is what it does.
Yeah, I understand that we can execute independent steps under a given scenario, but can you also execute multiple scenarios parallel?
Multiple scenarios at the
same. For example, I mean, I associate a scenario to a test case.
Yeah.
So this STC will I mean, I have STC and I have some four test cases. Can I run these 4 test cases parallelly across same environment?
Well, it depends what each of those things, the steps in each of those test cases, if they will interfere with each other, then you're not going to get predictable results. Then you probably should not.
So the scenarios tend to do things like define a topology, pull down a link, and see what happens. So if you run something else at the same time,
it may or may not interfere with each other.
So we definitely, like, if you look at the STC smoke test, there are some things that only require the ONOS CLI. And those can run in parallel with these tests that are bringing links up and down. There's no problem.
It's a function of whether the things you're doing interfere with each other or not. So you have the possibility to run things in parallel. That doesn't mean necessarily you can.
And if you need to sequence things, then you mark dependencies such that the guy who's mucking with the topology, if you need the topology, you depend on him. So you won't run until he's finished.
But the point here is that the scenarios define what should happen, and then we have the cell definitions, and we'll get to what those are. Cell definitions are effectively just a set of environment variables which define where things should run. And then we have also topologies, which specify, which basically is yet another sort of a dimension, which specify independently of what should be run, where it should run, but also which sort of specific topology or specific variant of the test, I guess, should run. So, we can, let's say we can run on a simple UK topology, or we can run on a more complex US AT&T simulation, or we can run even more complicated European research network topology. Same steps, same, different place where you run it. That's an execution environment, and different sort of the data set that you're testing with. So we try to separate those things. So the parallel chain, the parallel stuff is basically feeds off of an iteration variable. Let's say it can be specified like this. And effectively, we would be using, let's say we define our cells are defined in terms of OC1, OC2, OC3, OC4, OC5. That would be, and those hold IP addresses of the different nodes, 5 nodes in a cluster. Well, if you have all of those OC variables defined, if somewhere in a scenario we define $ curly brace OC hash and then close that, then this is a signal that this thing should be repeated or expanded into basically the parallel block should get expanded as long as the OCX, you can increment it. The minute we hit OCX that is not defined, then we stop the iteration. That should be contiguous. And so that basically will clone the subgraph according to this sort of. Okay. Okay, and then we can go next. Similar for sequential chains, except sequential chains allow us to define series of blocks, and essentially it's kind of like a for loop. You just iterate it, but they get strung together into a long strand rather than a parallel strand. This is not used as often as it's parallel. Okay, I already talked about dependencies. They can be inherent or they can be sort of injected. There's also hard dependencies, which means that this step not only must finish before I can start, but it also must succeed before I will start. Okay. If any of the dependent things fail that we have a hard dependency on, we won't even try to run. We'll automatically fail. Okay. But you can have soft dependencies, which are designated sort of by dash prefix before the step, which effectively means I should wait for it, but regardless of not whether it succeeded, I will run after that. Okay. So this is just an example of scenario of checking prerequisites before we even run. This is actually a real scenario. I mean, even on maybe an older version of it, right? So we define a scenario, we give it some name, then we define a group of steps. The reason we generally have a top-level group in each scenario is so that we can string them together. We can encapsulate the details. Think of this as sort of an encapsulation mechanism. So then we define a step to be able to check environment. This is where we make sure it's almost root, it's almost a NIC. Do we have at least OC1, and do we have some variables defined? And notice that we actually can put bash script extract in here, right? So it means it's anything, basically. So that's a step. Notice that one doesn't have any dependency, so it'll just run right off the get-go. It's one of the roots. Check ONOS bits. It's something that actually executes ONOS check bits. It's a script that we have, which does some probably more complicated logic that runs also without dependencies. And in parallel, we'll run all of these steps. Okay, there's only one step in this parallel group, which means make sure that passwordless login is possible against every OC. Yeah, exactly, against every node, right? And so notice that here we're just invoking simple SSH command right here, which will do an efficient timeout. Okay, so basically gives a thumbs up, thumbs down. Use it next. You see sort of an example of what it looks like, how it runs. And if you look at the timestamps, you can see that all of these things are launched in parallel. They're launched, these are the cyan sort of messages are start messages, the green or red are completion messages, green success, this is failure. Now, clearly you can tell also based on text rather than just by color. The colors provided purely just for visual distinction. And then you get, at the end, you get a summary, how many succeed, how many failed. Okay. We go next.
So, just a question: does whether something has passed or failed, it's totally based on the exit code of when you run that script, right?
Correct. Correct.
Okay.
Right now, we don't do any searching for patterns in the output or anything like that.
Yeah, you have to pipe them through the shell to grep to do that. There are some of them.
Something like
do that.
equal to true, like everything output should be true. or just checking the return code? That's what it's pushing.
This one is actually assuming that it must be true. Yes.
We also have the option of inverting the check.
Yeah.
So you can say fail if this is true.
Yes.
So that's like when you remove something and then you query it again, you want to fail if it didn't get deleted.
Yeah, but we can also ignore. We can also do a step that completely ignores. If you have the env attribute is the tilde, and that means basically ignore the exit code completely. Okay. So you don't have to wrap things that you don't care about the outcome. So it's just a simple overview, but the point is the definition of the steps is the scenarios, that's XML. The definition of the environment are the cells, which are just plain, basically bash file extracts which define environment variables. And definition of the topologies is just like cells, except it defines a different set of environments with the variables which describe some aspects of the topology to be tested and things to expect of the topology. Okay, so if you were to actually look at, do you have the ONOS code base in there? So if you were to just briefly, if you cd to the tools test directory, yeah, or you could look on GitHub, yeah, that will actually work just fine. Yep. Just scroll down to tools test. Okay. So you will see cells that contains the definition of the cells, scenarios contains definition of scenarios, and topos contains definitions of the test cells. So just look at cells for now, just so you can see. And just if you, let's say, look at the B3, okay, that's our bare metal cluster definition, right? This is where we define basically the key pieces are the OC1, OC2, OC3 that define basically the IP addresses of the three machines in a cluster. We also define which applications we should run by default, which applications should get ignited automatically, and that's drivers, null, and intent performance. We also, there's an environment variable called OCT that stands for, that's basically like a proxy, so that when you
we talked about it yesterday.
Yeah.
Basically, if the bottleneck link is between you and the cluster, then you can use this node to say like shuttle proxy the ONOS bits there, or you can SSH into that node and then run commands. It's also possible that like a dump server, exactly. Yeah. It's possible that like if you're using containers for 1, 2, and 3, that those may not have public IPs. So it's possible that OCT could be a publicly addressable IP, and then you use it as a jump server for SSH communication.
I think what this is missing is OCN. This may be an old definition. There's also OCN, which is for network node where many-net will be running. So if you were to go back and maybe look at different one.
Local or something?
Yeah, look at local, yeah. And the local one will actually, look at local. The local will probably be an example of what you could, what you could run if you were to running VirtualBox, for example. This is actually, if you were to probably ignite a bunch of Ubuntu boxes using VirtualBox, they'll probably be given these addresses 101, 102, 103 by default anyway. And so this is a definition file for running your own 3-node cell, actually 4-machine cell that includes the network node for your own stuff. It's a very simple file. You can modify it, you can create one, you don't have to check it in, doesn't matter. So that's that. If you were to go back now out of the cells and look at, let's say, the topos, just for kicks. So topos contains definition of our various topologies. Well, let's say you look at the default, recipe. Okay, so this is a definition. The .recipe files is what defines a topology recipe, and this is similar to the cell file, except it's concerned more with not with the environment where things run, but more describe the environment of the network that we will, the network topology that we will be using for testing. Okay, like this one, for example, says, you know, we should be expecting 600 ping-alls. There should be expecting 25 devices, 140 links, and 25 hosts. You know, and then there is some additional data that we expect for link up, link down scenario, expect each environment variables to be also defined. Okay, if we can go back, this is just a, you know, for the most part, you need to, if you look at one more test, one more up, you need to go outside of the top. And now look at the scenarios. So an example of the inclusion, if you look at, for example, look at the smoke scenario. This is the default scenario, smoke. Smoke, a little bit smaller at the bottom. There you go. Look at smoke XML. Yeah. Okay. If you scroll up, you'll see that it's a very simple file. Simple structure, right? We can import a whole bunch of other scenarios. And then we can stitch them together. And this, for example, say, okay, before we can run the setup, we better run the prerequisites and the network prerequisites. And, you know, then before we run the net smoke test, we make sure the setup is run. But here we can run completely independently. You can run maps CLI, which also requires setup, but it doesn't depend on NetSmoke. So these two can run together. And same thing for driver tests, same thing for meta ads. So notice that a lot of these things can run completely independent of each other. Actually, pretty much all of these things. And then, you know, then we insert another scenario, except that before we wrap up, we need to make sure, and this is where we inject the dependency for wrap up on setup, NetSmoke drivers, and so forth. And the tilde in here means that we don't care. They're sub-dependencies.
You probably want distributed primitives in there too, yeah?
Probably, yeah.
It's just the race that it usually finishes before.
Yeah, you're right.
Yeah. NetSmoke is the long.
Well, the thing is, our wrap up actually doesn't tear things down. It just collects logs and checks the logs, make sure that there are no exceptions in logs. So, but yes, it should absolutely depend. That should be the detail. If you were to take a look at just as in other scenario, just for kicks, just to see some other thing. Look at the setup, for example, just as an yeah. Mm-hmm. So this is the scenario basically that's used in the beginning, and you can see here. Okay, this you can see is the liberal use of groups, right? So we have the outer group of setup. Then within it, we have a couple of other groups. We have the cleanup group, and then we have install group, and then will be something else. And you can see that inside the cleanup group, we're running things in parallel. Like, for example, we're pushing bits in parallel, and so forth. And this one has evolved. You know, it started actually much simpler, but it's evolved because this one actually supports both sequential and parallel install. And you will see examples of things. We'll see how steps can be defined with inherent dependencies. You can see the use of the sort of iteration variable across the full, exactly. So this will actually be the number 1, 2, 3, 4, whatever is the iteration. So that's just at a high level. Those are the scenarios. Now there's the output. Both standard out and standard error are all funneled to one output, and the STC captures it and stores it away in a file for each step. So each individual step has its own log. We have a command called STL that allows you to view the logs of a particular step or particular scenario run.
It also captures the ONOS node logs, so that if you run one of these things on a cell, you get a failure. Cell gets torn down, you still have local copies of
So if you look up
ONOS logs.
Yeah, look at the wrap up. you see the wrap up. There will be a simpler, probably easier to digest scenario that does exactly what. Yeah. Okay, so you can see that the group that runs things in parallel checks the log, it checks them in place to make sure there's no errors, then it fetches them, and you can see, basically just fetches log, and yeah, that's it. Oh, yeah, I guess we remove that.
Yeah.
No, this is the main repo. This is whether or not all the, so you want to I think the idea here was to make sure that the main repo is empty.
Oh, right.
Oh, yeah. That we didn't bring in anything.
Yeah.
And transitive dependencies that get fetched.
Forget why we took that out. I guess because we didn't want everyone to have to delete that.
Yeah.
Yeah.
All right, so that's just a quick overflight of that. Now there's a variant of the STC invocation called STW. That one actually lets you run the same scenario over and over again, either for indefinitely or given number of times. The STL I already talked about, that's the view logs. There is a STCS, which is actually, you can just give it a sequence on a command line of individual, completely unrelated scenarios, and it'll run them in sequence until failure. And that's pretty much it. I think all of this documentation should be on the wiki also.
Some of it is. I was just looking at it. There's a lot. I don't know if I stopped in the middle or this presentation had more data than the one I started with, but there's a lot of this missing. So
there's
definitely
actually,
capture that.
yeah, there's actually some code in there to actually be able to have a GUI to this, be able to visualize the graph, but I aborted that project. I mean, it still can be resumed, but really the whole point is to run it, fire and forget. Yeah, the UI was really primarily only for debugging the process flow, that got suspended.
There's two scenarios that you're going to care about in connected to what we were talking about earlier. There's STC fast that Thomas was talking about. All that basically does is bring up a mininet, bring up some number of nodes for ONOS, bring up the forwarding app, and then try to do pings. And if that works, we're happy. STC smoke, which is the default behavior, does some more involved things like creating intents and creating flows and creating flow objectives and similar kinds of tests. It uses the same sort of mechanisms for sending pings and bringing links down and up and stuff like that, but it's using the API mode rather than the actual forwarding mode. So generally, we want to use fast for things like the Garrett verify job. That's literally just the stink test. Did you completely break anything OSGI related? The smoke test is probably something we want to run as part of master. Exactly. Part of the nightly or whatever.
Again, the reason this was done in a modular fashion so that you can run individual things. You can run it as part of semi-automated testing. Developers develop certain features. You want to do certain things to get, let's say you want to install a bit, I want to build it, install it, and start up a network and get it to a certain point, and then I want to do manual testing. And so which kind of things you run will then depend on what it is that you're testing. And the idea is to also encourage, it's done in modular fashion, so that encourages developers to do, as they develop, let's say I do some DHCP functionality. I might actually be able to write a scenario that describes, if I connect a mininet host, I should be able to see the DHCP message here. And so I want to assert that I've seen there is a mapping in my DHCP application for this new host. And so it encourages developers to write system-level functionality tests so that those tests can then be passed down the road to QA. Just like unit tests, but at a higher level. So that's pretty much all it, kind of high level.
So you're talking about maintaining STCS as one of the scope for this brigade. So do you think that this was an enhancement of STC should happen to this brigade?
So if So the primary thing, as our view is, would be for the brigade, it needs to be familiar with STC, so that because you need to know how to use it to make sure that it can be used to validate the various builds. Whether it's a release build, which is very infrequent, or whether it's a master build, which should be several times a day, nightly build, right, which is once a day at least, or the validation build, which is however often it needs. So you need to be familiar with it. Now, if in the process of becoming familiar with it, you see opportunities for improvement, by all means, please feel free to improve it. But I wouldn't necessarily suggest that that would be the first thing you do. Get familiar with it and get into the build would be and into the process. That's the first objective. And improvements, sure. Or development additional scenario, sure, why not? But that's not necessarily the core focus. And so related to this, right, clearly, so we talk about defining scenarios and running STC, those scenarios through STC. But then where do you run? This is, as a developer, that's fine. You can define your own set of virtual boxes, or if you happen to have access to our cell, loan infrastructure, where we can borrow cells. That's great. But now, if you want to run STC as part of the Gary validation build or master or whatever, you need now a place to run this thing. And multiple Gary jobs that we'll need to run. So how do we run multiple STC so they don't mess up with each other, right? So this is where the Warden comes in, the EC2-based Warden, which is where we can actually request cells to be created on demand in an efficient way, efficient both, cost-wise, and so this is where probably we can transition to discussion about the Warden. Okay. As a mechanism, basically, as a broker to allocate cells on demand, execution environments on demand.
Do you want us? How do you want to move that into that now? Do like an overview of what we have to speak? Okay. I can more or less
just kind of
take control of that. Do that. I don't have your little tool. Do you wanna briefly show kind of like what we have here? I can show it too, but I don't have your little widget.
But it's fine. You can show command line. It will convey the same thing. The widget is just a candy.
All right.
It's not essential.
Cool. Go back to the usual. All right. So actually, we went through this a little bit yesterday, but I showed you guys cell status, which shows the available clusters in the environment. There's also cell borrow, which will go to the Warden, and then the Warden coordinates the spinning up of some number of LXC containers.
Yeah, but this will work only with respect to your infrastructure.
Yes, they work with our infrastructure, but the idea is to replicate it also so that it is available, so that this works
across EC2 also.
On EC2 as well, and potentially even so that you can use the same infrastructure to work against different backends, different sort of providers of environments. It can be something on the VirtualBox, it can be your own home server if you want. It doesn't matter, right?
So somebody is working on that extension?
Well, so that's the next generation of the Warden. Okay, so for now, the Warden is effectively, think of it as basically a web server that runs in our lab in infrastructure. The cell borrow is basically a veiled curl request that does REST API. Simply, we have a couple of commands. We can borrow a cell, or we can extend the same borrow request can be used to extend the lease period. We can also return the cell, at which point in time the cell will be completely scrapped, meaning the LXC containers will be completely wiped out.
Something in there with the DHCP
What?
offered stuff.
So we have allocated.
Yeah, more or less. Yeah, we don't use the DHCP protocol, but yeah, we use curl commands that.
Yeah.
Yeah, instead of going over UDP ports, it's HTTP based. But yeah, more or less. Yeah, you can extend the current lease. You can return a lease. Yeah. But yeah.
Yeah, and we can get a list of available resources.
So
there's variants of the command which are described in the shared cells document. If you guys have access to it, but that will give you more usage nuances. But fundamentally, borrow, return, and list. And so what Brian just showed you was a list and a borrow.
Yeah, there's also cell return. What I should have done is shown you the status bit before, but let's start. Well, yeah, we'll do this. Cell status will show us there's 1, 2, 3, 4, 5 available cells. If I cell borrow, what we'll see.
So what's happening right now, there's effectively the REST request translates into the Warden, then basically goes and starts running allocation of this LXC containers. It shows us, we have these available slots. We have nine available slots.
So in this case, it assigned me cell alpha. 3 plus 1 means it's 3 cluster nodes plus 1 network node. And then I've got 119 minutes remaining because the default lease period is 120 minutes. But I can change that, I think, with a borrow, and then I just throw a number after it.
Well, yeah, I think your number, yeah, you could say 300. Yeah.
So it basically provides you an SSH-based access.
Right, yeah, so what it's going to do is it's going to copy my public key, I think, into the cell environment. So I can now do SSH SDN at whatever this thing. I can also use the environment variables that are set. If I look at there's a bunch of environment variables. Well, yeah. Where do we start? So these are the switches, the switch and host.
Yeah. So some of those are synthetic environment variables.
These are devices, hosts, whatever. Interesting ones are kind of the OC variables. So OC 1, 2, 3, 4, whatever. So I can say SSH SDN at $OC1, right? And then we're on the first node in the cluster. So, okay. So then there's the borrow thing, which we did, right? And if we look at status again, after borrow, you'll see that now my lease is 300 minutes long. If I do a return, well, let me do this first quickly. STC fast. I can show you that STC can be run against these clusters, and you'll note that the nodes it's using, 1, 2, and 3, are the same nodes that were borrowed from, exactly. So this will run, and then we can return the cluster, and the nodes will go away, my key will get revoked, etc.
So every time when you allocate a different user, it will do a fresh install, or you have some stale.
Well, so there's a snapshot of the LXC container, effectively, that gets cloned every time. Okay. So it's a clone, and then there's an injection of the user's key.
Okay. And the snapshot is just bare runtime environment, so it has JRE, Pro, and other stuff, but it doesn't have any ONOS bits on it. The ONOS bits get installed on there. The idea here is that this leads to, yeah.
Sorry?
Injecting ONOS is Java with CC.
Correct. Yeah, setting up the environment for the user based on the request that they've made is the job. So this will run eventually. While that's running, I can show you over here. So the first version of the Warden we have on GitHub is in branch 0.1, and it's basically a server and client. So the server is written in Java. It's got a servlet, it's got the main logic, it's got a reservation definition, and then main which just kicks everything off. So there's also the clients that Thomas was alluding to. One of the clients, this is the little whatever it's called.
It's a Mac
Swift
little
application or whatever that runs up here that you can look at the cells via that instead. The cell command actually is a function, I believe, right, that's defined in mdefaults.
Yeah, exactly. It's a function which injects environment variables that reads them, basically sources the cell files into the environment, and based on those environment variables, then it derives additional ones, so that to make it easier for scripts, so that let's say if you have some scripts that need to know an enumeration of all of the environment variables, they don't have to do their own enumeration. They can just rely on some synthetic environment variable.
So you can see, function cell basically has a couple of special cases. Borrow, which we use, return, which we use. These are just shell, curl commands. Status, which we used as well. And then if you don't specify anything, it just prints out some of the environment variables that would have been set as part of your cell. And then everything else, it will look in the tools test cells directory in case you've had something that you've written down, so you can specify a cell that way. So that's the version of the Warden that we have running in the lab here, is the source code running here. Now, as Thomas alluded to, we sort of were working on something new. Great, yeah. That file doesn't exist because I deleted it, I think. So what we did here is we first started by defining a proto spec version. So instead of just using JSON, we now have a message type for cluster, request, and advertisement. So requests can be status, reserve, return, extend. The spec is number of controller nodes, a username, a user key. These things have duration, and then there's this notion of a cluster ID, cluster type. So cluster ID would be like the name you were seeing before, Alpha, Bravo, Charlie, whatever you want to call them. Cluster type is, both of these things are optional, like everything in protobufs, but could be an EC2-based cluster, an LXC-based cluster. You could have clusters that are, EC2 EU, EC2 India, EC2 China, EC2 whatever. So, we could potentially have, different flavors of these clusters that help sort of distinguish between them. And then the advertisements will basically say whether a cluster is unavailable, available, reserved, ready. And then it will contain cluster nodes, a head node IP. This could be your jump server.
But cluster type should be enumerated because the implementation would depend on the cluster type. Implementation contacts the backend.
Yeah, so cluster type is a preformed string, basically.
Yeah, so I can give anything, right?
You can give anything, yeah.
But then there is no cluster type called Vishwa.
Well, so we haven't gotten there yet. So the role, there's going to be three components in this.
Document for the bring up the shared cluster document that has actually a picture that shows the new visual of the architecture. Shared cells.
Shared.
So this is the existing usage, and we also have a screenshot, I think, of the little widget.
The notification widget thing that I said I didn't have installed.
Yeah. And then we have the next generation, which actually sort of shows the pictures.
Mm-hmm. Yeah. So the idea in this this next evolution is that you've got a Warden server that kind of acts as a broker, and then you've got a series of agents. The agents, when they register with the broker, are effectively the type, and then the cell name is the cell ID. So together, you take an agent name, which is type, we can rename that, and the cells that are advertised by the agent, and you've got a unique parent. So the idea would be that, you know, you could have 3 different, you know, if you have 3 nodes here in ON.Lab, you could register them all with the same warden. I mean, theoretically, you could have some policy around, you know, who can access which cells based on which warden and what their, you know, their user credentials are, whatever. That's not really the purpose here. Our goal, you know, just to get this up and running was just to do the orange boxes. Have an EC2-based agent, which knows how to provision cells in EC2, have a basic broker, which is the Warden server, and then have a basic gRPC-based client, which can make requests and return requests. And so if we go back to the source code, yeah, we've got the message protocol and the services defined. So there's an agent service, by which agents can stream, agents can receive
requests and send advertisement. It's the source of the request is agent, right? It's directed towards the server.
Right. So this is the service that would be implemented by the
warden.
By the warden.
By the server, yeah.
Yeah. So the service gets implemented by the server in both cases. And yeah, when an agent connects, it will receive requests and return advertisements. When a client connects, it can either use synchronous API, so it can request lists and just receive.
So Warden is something like interface and agent implementation of this service.
Yeah, exactly.
So the broker.
So the warden in this case, yeah, would be the broker. It implements both services, and then it can accept, you know, 1 or more client requests, and it can have 1 or more agents connect to it. And then it basically serves to, you know, as a repository for the clusters or the cells that you have available, and then it pairs those available cells to requests that come from clients. Exactly. And so this whole thing is Go-based now. So just to give you an overview, there's you know, a dummy agent, EC2-based one, LXC-based agent, and then some common functionality between them. We've got a streaming-based client, which can make multiple requests, receive multiple replies. A blocking client using the blocking API. This is the Mac app, which hasn't been ported yet to use the gRPC. So this is, you know, largely a work in progress. And then server is the Warden implementation. So it's got the broker and the implementation of the gRPC interface. So this is, you know, I wouldn't say, yeah, it's still largely a work in progress. The goal was just to get you know, this pipeline working where you can have a server running on EC2, run a Warden agent, and then be able to provision these cells for, you know, Jenkins at first, who are going to connect and ask for them. So, yeah. I mean, obviously, there's, you know, a million different directions and things we can do. You know, we could try to plug the cells that we have in our lab here into the server and make those cells available via common Warden. We could open up the client API such that, you know, people within the community could potentially access cells. If you had test labs or something at a company that you wanted to make available for certain types of testing, that would have
SPC as a service.
Sorry?
SPC as a service.
Yeah, SPC as a service, or, you know, ONOS developed environment as a service. You know, there's an opportunity there. How much of that we actually want to do, I don't know. I mean, I think we develop as much of it as is useful for the purposes of our testing at first, and then if it becomes broadly more usable, people can take it from there.
Thanks, Ray.
I mean, there's other ideas, you know, instead of having LXC as a backend, potentially using something like Kubernetes or Docker Swarm as a backend for allocating containers. Is another possible direction as well. But.
Could you share these Docker Swarm so that we can...
Okay, I'll give you control back and we can go over tomorrow's schedule if you want.
That's it. Yeah, again on time.
Okay, let's see. Well, do we want to try to slot some of those topics in or just talk about that tomorrow?
Yeah, I mean, what is this there? So this is over. So this is done. Release process scripts, dev scripts, and build.
Right.
Okay, we'll just start here.
We on time still?
Yeah.
On time.
Just trying to slot tomorrow.
I see.
So, tomorrow morning, we kind of, do we want to do more content in the morning and then in the afternoons spend time?
Available in the morning.
Oh yeah, that's not available. So, Zach, do you have a preference for how we do tomorrow's morning schedule?
Yeah, I'm probably going to be gone between 10 and 1, so I know that eats up, like, that would cover most of the day. Of all the things that I don't have anything in particular that I absolutely feel like I need to look at here on in. I mean it's all important, but there's nothing that I can look at that I think that I wouldn't be able to pick up by listening to the transcript or something. So it's I defer to you guys to decide.
Okay. The other thing we could do is we could. Well, okay. Yeah. Well, what do you think, Bishop? What do you want to do?
About 10 a.m. Pacific, there is a call with all Brigade aides. It'll be good if you two can join.
Okay. Do you want to put that at 10? The
Yeah, 10 to 11. I think we'll be there.
Which one now?
The Brigade.
Gotcha.
Brigade call. Okay. So this is Brigade community. All right. So we'll do that in the morning, and then we can talk about. I think we should do this after, to be honest. I don't think it makes any sense to do it before. We can talk about these things, the release process scripts and the dev scripts. We can have a short debate about Bazel after lunch, and then we can focus on what our short-term plan is, schedule for deliverables, and then process, sync up, we'll schedule a meeting time, stuff like that.
Yeah. How do you need? Yeah, here. After 3:33. She'll be here. We would need you from 2:30 to 3:30. Wanted to. Yeah, wanted to.
All right, what do you